All right. Now, I'd like to give you a short introduction to Digitode before we actually begin the session with Govardhani. Now, Digitode, as many of you all already know, we are working with academia in particular as well as industry. We focus on research and academic solutions, specializing in test and measurement, industrial automation, 5G, 6G wireless technology, AI-driven IoT tech solutions, quantum technologies, and advanced robotics. Now we have our partners across all these solutions. We work with ST Microelectronics, Digilent. In the quantum domain, we work with QU Tools, qBraid, VRV Solutions. For high-performance computing and for servers, we work with Advantech. Wireless, we work with TMY Tech and Mantis Wave. And for robotic solutions, we work with Crowbot Technologies. We are authorized partners of all these companies. Now, these are the domains we specialize in. When it comes to quantum and optical solutions, we work with high performance test and characterization systems for quantum communication, fiber optic networks, and photonic devices. And in 5G and 6G wireless solutions, we work on advanced wireless testing and prototyping research solutions to enable next generation communication technologies. In FPGA development and VLSI design, we do designing, verification, and prototyping for advanced computing and hardware. With AI and machine learning technology, we work with on edge AI, OT, industrial IoT, and vision AI workflows to enable real-time intelligence in embedded applications. In automated test and measurement, we work on end-to-end solutions in sensing and data acquisition built for high performance, real-time monitoring across industrial and academic applications. With this, let me welcome you once again to this session, and let me hand over to Govardhani to begin today's session. Over to you, Govardhani.
Just a minute, Anup. Let me do the setup.
Now, for the participants who have registered but could not join due to any other engagements, we are also recording the session. We would email you the recording, as well as we'll update the recording on our website at www.digitodetech.com.
Hello. Am I audible, Anup? Can you check?
Yes, Govardhani. We can hear you. Okay.
Okay.
All right. Before you go, I'd like to make another announcement. Some of the participants have requested a e-certificate for attending both the days. So if you are attending on both the days, and if you would like a e-certificate, in fact, for everyone who's attending these 2 days workshop, we will be sending you an e-certificate within a couple of days from when we close. So you can expect something on an email from us early next week. Thank you. Over to you, Govardhan.
Okay. So, good afternoon, everyone. First of all, thank you for being a part of this faculty development program on quantum computing fundamentals with the qBraid platform. So, today we are going to explore a technology that is often misunderstood, like sometimes overhyped and yet extremely powerful, quantum computing, right? So, now before we go into technical depth, let me set the context clearly. So, this session is not about physics equations, or it is not about replacing the classical computers. It is about understanding what quantum computing really is, why is it important, and how it works, and how we can actually teach and use it in the academic environment. So, by the end of this session, you should feel comfortable explaining the quantum computing to your students and also running a quantum program yourself. Okay, so let's begin. So, my name is Govardhini, and I work as a solution engineer at Digital Technologies Private Limited. So, my background is primarily in IoT systems, working with microcontrollers like STM32, connecting devices to cloud platforms like AWS, and handling real time communication with MQTT and building end to end prototypes. Over the last few years, I have also been working with quantum platforms like qBraid, where we help institutions set up quantum learning environments. So today's session is not just theoretical, so it is based on a practical implementation and real development experience. So my goal is to make quantum computing simple, clear, and approachable for you. Okay, so let us look at today's structure. We will begin with fundamentals, what quantum computing is, and how it differs from quantum, like classical computing. Then we will move into understanding quantum circuits and gates. Okay, so after that, we will discuss how quantum computers are accessed in real life through cloud platforms, and then we will understand qBraid and how it simplifies the entire workflow. And finally, we will move into hands-on mode where we will actually execute a quantum program. So the flow is concept, mechanism, platform, okay, and execution. So let's move. Now let us start from something very basics. That is, let me just close this screen. Okay. So now let us start from something very basic. Okay, so all of us are familiar with classical computers, right? So a classical computer stores information using the bits. A bit can be either 0 or 1, nothing in between, no mixture or no overlaps, right? So even when we run large programs or AI models, everything internally is still zeros and ones. Now imagine I give you three classical bits. Okay, so how many possible combinations can we represent? It will be like 2 power n, so 2 power 3 means it will be 8 combinations, right? So but at any given moment the systems hold only one of those 8 combinations. Now let us look at quantum computers. Like quantum computers use something called qubits. Okay, so a qubit is different from a bit. Like a qubit can be 0 or 1 or both at the same time. Okay, so this idea of being in multiple states at the same time is called as superposition. Now here is where it becomes interesting. Like if I have three qubits, they can represent all 8 possible combinations at the same time. Okay, not one at a time, it is simultaneously it will happen. So this is why people say quantum computing has exponential powers. Okay, but and this is very important. Like quantum computers do not simply give all the answers instantly. We must carefully design algorithms so that correct answers becomes more likely before we measure. So quantum computing is not magic. Okay, so it is controlled probability manipulation. So what is quantum computer? Now let us slow down and clearly understand two important terms on this slide, like what is quantum computer and what is quantum computing. These two sound similar, but they are slightly different. Let us start with the first one. Okay, so what is quantum computer? A quantum computer, it is like a machine. Okay, it is a machine that performs the computation using the quantum bits. Okay, so these quantum bits are also called like qubits. So instead of classical bit, it will be using this qubits. In a classical computer, the smallest unit of information is a bit. Okay, a bit can only be 0 or 1. Everything your laptop does, from running Excel to training AI models, ultimately reduces to operations on zeros and ones. Okay, now in a quantum computer, the smallest unit of information is qubit. Okay, and this is where things change dramatically. Like a qubit is not limited to just 0 or 1. Okay, it can exist in a combination of both 0 and 1 at the same time. So this is not a software trick or something. Okay, this is a properly of nature itself. So quantum computers are physical systems built using the quantum mechanics. mechanical particles like superconducting circuits, trapped ions, or photons. Okay, so these particles behave according to the rules of quantum physics. Because of this, quantum computers can represent and process information in ways that classical systems simply can't. Okay, so but here is something very important. Like a quantum computer is not just a faster classical computer, it is a completely different computational model. Like it does not replace classical computers. Okay, it works alongside them for specific types of problems. Okay, so now the slide says quantum computers allow solving certain complex problems much faster, right? Notice the word certain. So quantum computers are not faster for everything. If you want to open a browser or write a word document, quantum computing is useless there. Okay, so but if you want to factor very large number or solve complex optimization problems, simulate molecules and chemical reactions, and solve certain search problems, then quantum algorithms can offer significant speed advantages. Why? Because of how qubits behave. Okay, so within n classical bits, we can represent one configuration out of 2 power n possibility configurations, right? But with n qubits, we can represent all the 2 power n configurations simultaneously in superposition. Okay, this is called as exponential state space. Okay, this ability allows quantum algorithms to explore large solutions spaces more efficiently when designed correctly. Okay, so that explains what quantum computer is. But what is quantum computing? So quantum computing is the process of method of computation that uses the law of physics to process the information. It is not just about hardware here. Okay, it is about how information is represented, manipulated, and measured using the quantum mechanics. Okay, so in classical computing, information are stored in bits and operations are done using the logical gates. Outputs you will get on the deterministic result. Similarly, in quantum computing, informations are stored in qubits and operations are done using the quantum gates. Instead of logical gates, here you will be doing the quantum gates. And output will be probabilistic results after the measurement. Okay, so quantum computing relies on three fundamental physics principles, that is superposition, entanglement, and interference. So let us briefly connect them here. Talking about the superposition, it will allows a qubit to exist in multiple states at once. Okay, so think of it like this. A classical switch is either on or off. A quantum switch can be on and off at the same time until you check it. Okay, so talking about the entanglement, like entanglement connects qubits in such a way that the state of one qubit directly affects the another's. Okay, even if they are physically separated. So this allows quantum states to encode correlations that classical systems cannot efficiently replicate. Okay, and talking about interference, so interference allows us to simplify correct solutions and cancel the incorrect ones. Okay, so quantum algorithms use interference to increase the probability of measuring the right answers. Okay, so now as faculty members, this is very important to communicate clearly to students that quantum computing does not mean we get all answers instantly. Okay, but when we measure a quantum system, it collapses into a single classical outcome. So the real power of quantum computing lies in designing the algorithms that manipulate the probability amplitudes before measurement. So that is the art and science of the quantum algorithm design. Okay, so let me summarize this slide in very simple words. Like a quantum computer is a physical machine. Okay, and quantum computing is the method of computation using the quantum physics. And classical computers use bits, where quantum computers use qubits. And classical systems follow binary logics, and quantum systems follow probability amplitudes. Okay, and classical results are deterministic, whereas quantum results are probabilistic. So when we talk about quantum computing, we are not just talking about the faster machines. We are talking about a new computational paradigm, like one that leverages the fundamental behavior of nature at microscopic scales to process the information differently. Okay, and that is what makes it more revolutionary also. Okay, and how, let's switch to the next slide. So here we will be seeing how quantum computing works. So now that we understand what a quantum computer is, the next natural question we'll be having, like, how does it actually work, right? So let us break this down slowly and very clearly. I want you to forget the complexity for a moment and imagine something very simple. Like, let us compare quantum computing to the cooking. Okay, so when we cook a dish, what do? We take a raw ingredients and we apply certain operations like cutting, mixing, or heating, and later we let the cooking process happen, right? And later we taste the final dish. So quantum computing follows a very simple structure, a similar and simple structure. Like, instead of ingredients we have the qubits, right? And later we have the quantum gates instead of cooking actions. So instead of stove we have the quantum processor, and instead of staging we will measure the result. So the structure is prepare, transform, execute, and measure. So now let us go deeper into this stage. In classical computing, when you start a program, memory bits are initialized, usually to 0. Okay. And similarly, in quantum computing, we begin by preparing qubits. Okay. Typically, all qubits starts in default state called 0. Now think of 0 as a blank sheet of paper. Okay. Nothing is written it. So it is clean starting point. If we have 3 qubits initially, the system is in state of 000. Okay, so which means all qubits are 0. This is called as initialization. In real hardware, this means physically preparing the quantum particles into a ground state. Okay, so preparation is about setting the system into a known starting condition. Okay, until this stage nothing quantum special has happened now. Okay, now comes the real action. We apply the quantum gates. Okay, let us compare this sculpt like clay. Okay, so you start with a simple lump of clay, then you shape it, and then you will stretch it and twist it and crave it, right? So quantum gates shape the quantum states, but instead of shaping the physical clay they shape the probability amplitudes. Okay, so for example, if I apply a hadmat gate to a qubit, like initially in 0, it will become in a superposition of, it can be 0 or 1 at the same time. So this means the qubit is now in the superposition. Now imagine we apply more gates, like each gate changes the wave like nature of the qubits. Now here is very important concept for the faculties, like quantum gates do not directly give us answers. Okay, they manipulate probability amplitudes and they change the internal mathematical structure of the quantum systems. Okay, so think of it like adjusting the volume levels of multiple speakers. Some get louder and some get softer, right? So quantum algorithms carefully adjust the amplitude so that correct answers get amplified. Okay, so when we run a multiple gates in a sequence, right, the entire structure is called as quantum circuit. Okay, but imagine a maze, okay, with thousands of possible paths. In classical computing you try one path at a time. Okay, in quantum computing the superposition also allows you to explore all the paths at the same time. This comes with the nature of superposition. So the order matters, right? So if you heat before mixing, the result changes, and if you mix before heating, the result changes. So this evolution follows all the laws of quantum mechanics. Okay, so talking about how do we actually use the quantum computers today. So instead of building the quantum computers, what do? We will build some algorithms, but we don't know how to run those algorithms, right? So how do we actually use the quantum computers today? Do we have quantum computers in our laboratories? No, right? And do we install them like we install CPUs? No. Why? Because quantum computers are extremely delicate machines. They are not like laptops or servers. Okay. So most quantum processes operate at the temperature close to absolute zero, around minus 273 degrees Celsius. Okay. And that is closer, like colder than outer space. So why such low temperature? Because quantum states are extremely fragile. Okay. Even tiny vibrations, temperature changes, or electromagnetic noise can destroy quantum coherence. So this phenomenon is called as decoherence. So quantum computers require cryogenic cooling systems and vacuum chambers and shielding from electromagnetic interference, as well as ultra precise control electronics. Okay, so this makes them large, complex, and expensive. So universities and researchers do not usually build them independently. Instead, we access them remotely, right? And this is where cloud based quantum computing comes in. So let us compare this with something familiar like cloud computing. So years ago, companies used to maintain their own servers, right? So today, most companies do not build their own data centers. They use AWS, Azure, or Google Cloud. Similarly, we do not build our own quantum hardware. We use quantum cloud platforms. Okay, instead of installing a quantum computer in our building, we connect to the one over the internet. Okay, so now let us walk through what actually happens, like step by step, right? So look at the image in the slide. On the left, you see a person writing a Python code, right? And that is the first step. We write the quantum programs using the Python. And next, we use quantum SDKs such as Qiskit, Cirq, or others. This code defines the quantum circuit, meaning which gates we apply and in what order. So the entire quantum algorithm is written as a code. So now once we write the code, what happens? We send it to the cloud platform. In the image, you see the cloud labeled Global Cloud Platform, right? So this cloud acts as an interference. It handles authentication, job submission, scheduling, and backend selection. Okay. Now from the cloud platform, the job is sent to the remote quantum processor. Okay. Look at the right side of the image. You see a tall cylindrical structure, right? That represents a real quantum processor. Okay, often a superconducting quantum processor inside a dilution refrigerator. So this processor applies the quantum gates physically using the microwave or laser pulses. Okay, it runs the quantum circuit, then it performs the measurement, right? And then it sends the classical results back to the cloud. Now, once the hardware finishes execution, the results are returned to the cloud, and then we receive the measurement outcomes on our local systems. Okay, what do these results look like? Typically, they are like counts. After running the circuit for 1,000 times, we might get like state of the qubits occurred these many times. So this tells us the probability distribution of measurement outcomes. Okay, and then we will analyze the distribution to interpret the solution. Next, let me clarify something very important here. Like when we say we run a quantum program, we are not sending classical instruction to a normal CPU. Okay, we are sending a circuit description. Like the hardware then physically evolves quantum states according to the quantum mechanics, and what we receive is statistical measurement data. Okay, so quantum computing today is hybrid. We use classical computers to write a code, send the job, receive results, and analyze. And quantum processors perform the quantum part of the computation. Okay. And another way to think about it is like a laboratory instrument. Imagine you have a very expensive microscope located in a national research lab. You cannot own it like personally, right? So but you can book time slots. So what you'll say, you send your sample, the lab runs the experiment, and they send you the data. That is exactly how quantum computing works today. The quantum processes is like a scientific instrument, okay, and you submit your experiment in the form of quantum circuits, and you receive the measurement data and you interpret it. Okay. So for academic institutions, this model is extremely powerful. It means students can experiment with real quantum hardware without owning it. Faculty can teach quantum programming without worrying about the hardware complexity. Okay. And institutions can integrate quantum computing into the curriculum without infrastructure investment. So this democratize quantum computing. Okay. And when you press run on a quantum job, the SDK converts your circuit into a backend specific format, and the cloud platforms will validate it. The job enters the queue, and when hardware is available, it will execute. Okay, so about the quantum circuits and gates. Now, let us address a very important question. Like, if quantum computers are so powerful, how do we actually tell them what to do in classical computing? We write programs, right? So we use instructions like if, else conditions, and add or multiply, and loops like while loops we will be creating. But quantum computing does not use traditional instructions in the same way. Instead, we use something called as quantum gates. Okay. And when we arrange these gates in order, we perform a quantum circuit. Okay. Imagine you have a robot and you cannot just tell it solve this problem, right? So you must give it a specific step by step instructions like turn left, move forward, or some clear instruction. So similarly, quantum gates are the instructions we give for qubits. Okay, they tell qubits how to change. A quantum gate is an operation that changes the state of the qubit. Okay, remember qubits are not simple zeros and ones, they exist in superposition also. So when we apply a quantum gate, we are not flipping a bit there, we are rotating a quantum state in a mathematical space. Okay, this space is called as Bloch sphere. Okay, think of Bloch sphere as a globe, and a classical bit can only be at the north pole or the south pole, but qubit can be anywhere on the surface of the globe. Okay, quantum gates rotate the qubits on the globe. Okay, so that is why we see quantum gates manipulate probability amplitudes. And what is quantum circuit? So quantum circuit is simply a sequence in which we apply the gates. Think of it like a recipe. Like if I add sugar before heating, I get one result. And if I heat before adding sugar, I get another result. So order matters, right? In quantum computing also, like order is critical. If I apply Hadamard gate and then C naught, I get entanglement. If I reverse the order, I get something completely different. So a quantum circuit is full plan of how qubits evolve over time. Okay. So the step-by-step process will be like start with initializing the qubits, and then we will be applying the gates one by one and let the quantum states evolve, and we will measure the final states. Okay. So the circuit control how qubits change. That is the entire purpose of using the circuits and gates. In classical computing, we have the logical gates like AND gate or gate, not gates, right? But these gates operates on like definite bits. In quantum computing, we have Police XYZ gates and Hadamard gates, CNOT gates, swap gates. So these operate on probability amplitudes. Okay, and classical gates are irreversible in some cases, but quantum gates are reversible operations. That is the key difference. Okay, so now let us understand each quantum gate by comparing it with something very simple. Okay, so talking about the Police X gate. So think of it like a light switch. Okay, if the light is off, you press the switch, it becomes on, and if the light is on, you press the switch, it will become off. So that is exactly what X gate does. If the qubit is 0, it becomes 1 if you apply the X gate, and if the qubit is 1, it will become the 0. Okay, so in simple terms, X is the quantum version of NOT gate. Okay, but here is a deeper part, like if the qubit is not just on or off, but in superposition, like a dimmer light halfway between on and off, then X rotates that state. So X is not just flipping the switch, it is rotating the state like 180-degree around the x-axis of the Bloch sphere. Okay, but for beginners, remember this: X is like a flipping gate. Okay, now talking about the Z gate. Z gate is completely different. Like imagine two students walking in a rhythm, okay, at the same state. And if one student suddenly changes the direction but continues walking, okay, the distance between them changes. The Z gate does not flip 0 to 1. Instead, it changes the phase of 1. Okay, like what does it mean? It changes the sign of the amplitude. Okay, think of it like changing the sign of mathematics. Like plus 5 becomes minus 5. Okay, the number is still 5 in the magnitude, but the direction changes. So why is this important? Because quantum interference depends on this phase. Okay, if two waves are in the same phase, they add. If one wave is inverted, they cancel. Right, so Z gate is like flipping the direction of a wave. So simple definition we can say is Z is for changing phases, whereas X is for flipping the bits. Okay, now talking about the Polish Y gate. So the Y gate is like a combination of X and Z together. Okay, imagine like spinning a coin and twisting it at the same time. Okay, so flips the state like X, but also introduce a phase change like Z. Okay, so if X is a horizontal flip and Z is a vertical phase change, Y is like a diagonal transformation. Okay, so in simple words, we can say Y is equal to like flip plus twist, both the things. Okay, so talking about the Hadamard gate. So this is one of the most important gates. Think of Hadamard gate like tossing a coin into the air. Okay, before tossing, the coin is definitely heads or tails, right? After tossing, it is spinning in the air, not yet decided, like whether it is head or tail. So that spinning coin is superposition. So if we apply H to the H is nothing but a representation of Hadamard gate in alphabetical manner. Okay, so if we apply the Hadamard gate to 0 bit, okay, it becomes an equal combination of 0 and 1. So the qubit is now in both 0 and 1 until measured. Okay, and Hadamard is what opens the door to quantum parallelism. Like without Hadamard, there is no superposition. So remember, Hadamard gate will create the superposition. Okay, now talking about the controlled gate, that is C naught. Now imagine you tell someone if the light is on, okay, then open the door. That is a conditional instruction. Okay, C node works like that. We have two qubits and one is control and one is target bit. So if the control bit is 1, flip the target. If the control bit is 0, do not do anything. Why conditional? This conditional behavior is extremely powerful. Why? Because when control qubit is in superposition, the operation happens in the superposition itself. So this creates entanglement. Now imagine two coins spinning. If they are entangled, whenever you look at one and see heads, the other is automatically head. Okay, and C naught is the gate that create the relationship. So remember, if you want to remember C naught in a short term, it is like a conditional flip. Okay, so if control is 1, you need to flip the bit. If it is not, do not flip the bit. Now we'll move to the another gate, that is the swap gate. Okay, so here imagine two people sitting in a chair. Okay, and swap gate simply makes them exchange seats. If qubit A is 0 and qubit B is 1, after swapping A becomes 1 and B becomes 0. That's it. So why is this important? Because in real hardware, not all qubits are directly connected. All right. Sometimes we need to move quantum informations physically. Swap helps rearrange the positions. So in short, you can remember swap gate as exchange positions. Okay. So let us summarize all the gates in one simple way. X is used for flipping the qubits and Z is used for changing the phase, whereas polis Y is used for flip plus phase shift. Okay. And Hadamard gate is used to create the superposition state, and the C node is used for conditional flip, whereas swap is used for exchange the positions. So these are like basic tools. Just like in classical computing, we build complex programs using and or not, right? In quantum computing, we build algorithms using Hadamard gate, Polis X gate, Z gate, Y gate, and control not gate, and others. There are even more, okay? And complex quantum algorithms are just combinations of these simple transformations. So classical gates manipulate definite bits, quantum gates manipulate probability amplitudes. But classical logic moves between 0 and 1. Okay. But quantum logic rotates state in continuous space. And so instead of thinking 0 or 1, we must start thinking in terms of rotations and interference. Okay. So now that we understand what quantum computing is and how it works, what gates are, and how circuits are built, the next question is like, how do we actually get started with? All right. So, especially for faculties who are new to this field, let me simplify this completely. Like, first, quantum computing uh, today does not require you to build the hardware, right? You don't need cryogenic systems, you don't need superconducting labs, you don't need vacuum chambers. Okay, everything is accessible online. Just like how we use Google Colab for Python, we now use cloud platforms for quantum computing. So the first requirement is beginner friendly tools. That means no installation complexity, no hardware dependency, no deep physics requirement at the beginning. Okay, so we start with simulation environment and cloud access. So this removes the biggest fear, infrastructure. Second, the quantum computing cannot be learned randomly, right? It requires structured progression. Why? Because it combines linear algebra, probability, computer science, and quantum physics. So if someone jumps directly into coding without understanding the superposition, they get confused, right? So if someone studies theory without coding, they lose interest. So we need structured content like basics of qubit, gates and circuits, superpositions, entanglement, and algorithms. And this structure should be available for both students and faculties. Without structure, quantum computing becomes like overwhelming. Now let us break it down practically. So to learn quantum computing, we need three things, like not more than that, just three. A place to write and run the quantum programs, just like we need an IDE for quantum programming, like programming in C or Python. We need an environment to write a quantum programs, right? And this environment should allow us to build quantum circuits, add gates, visualize the circuit, and execute it. If writing code becomes complicated, beginners will drop out. So we need a clean, accessible interface. Now, quantum simulators to practice safely. Now, here is important, very important, like real quantum hardware is expensive and noisy because of qubits, non-static states. So we don't directly start with the hardware, we start with the simulators. think of it like this. Before flying a real airplane, what we'll do, we will just use the flight simulators, right? So similarly, before running on a real quantum processors, we use simulators. Simulators allow us to test the circuits, understand the behaviors, and observe the probabilities and make mistakes safely. So this is extremely important for education purpose, right? Studying purpose when you are jumping for the first time. And next, what we need, like access to the real quantum computers when needed, right? So once we are confident, we can run the same program on the real hardware, and this is powerful. Okay, so because now we see a real noise and we observe the hardware limitations here, and we understand the practical constraints also. Okay, so this bridges the gap between theory and the real world implementation. And another thing we needed is an easy way to run the program and see results. Finally, the most important thing, like if running the program is complicated, faculty will not adopt it in a classrooms, right? So we need one click execution and clear visualization of results, histograms and probability distributions and job status tracking. So if the experience is smooth, learning becomes engaging, right? So before jumping to the next slide, let me summarize this slide. So to start with quantum computing, we do not need hardware. We need the right platform, a platform that provides learning structure, coding environment, simulators, hardware access, and simple execution. And that is where platforms like qBraid comes into the picture. Okay, so as faculty members, the key concern will be like, how do we introduce this to students without overwhelming to them, right? So the answer is like, start with simulators and later focus on the concepts and gradually introduce the hardware, and then use structured labs and keep the interface simple. Okay, so the quantum computing should feel like programming, not like advanced physics. And now that we understood what we need to get started, let us see how qBraid actually provides all of this in one place. Okay. Now let us understand what actually happens inside the. So we are calling qBraid like a one-stop quantum computing platforms. Why? Because it gives you access to multiple real quantum computers on the backend, like where you will create your own algorithms and then you will deploy those on the quantum computers. Okay, and you will also get access to the high performance simulators from different providers like AWS and IQMs and all. Okay, as well as here the programming which you will be using is Python, which is an easy and starter coding language. Okay, and here you also will get a ready to run quantum circuits and notebooks available, where you do not always need to switch to the SDK or qBraid lab to run any programs. In the qbook itself, after the explanation, we'll be having a bunch of codes. You'll just click on run and it will display the quantum circuit, like result of that program there, then and there itself. Okay, and you will also get access to the preloaded learning modules through the qbook. Like if you are a starter, like if you are a beginner of quantum computing, there is some like bundle of courses you can access through, and you know the basics of quantum computing, but now you want to start developing a quantum cryptography algorithms or any different algorithms like quantum machine learning algorithms and variational q algorithms, right? So for the intermediate level also there is, and for advanced level they are providing a like software engineering level course. Okay, so yeah, there are different modules available when you go through this website. Okay, I'll just show you what are the preloaded learning modules available. Okay, so qBraid lab environment. So we are talking about qBraid lab, but how it actually works when you are programming it, right? So now let us understand what actually happens inside the qBraid lab environment. So this slide shows something very important abstraction. Like at first glance, this might look a little bit of technical, but I'll simplify it completely. Okay. First step, like quantum program, we begin by writing the quantum program, and this could be written using Qiskit, Circ, or any supported SDK from the qBraid. Okay, so from the user perspective, we are simply writing a Python code. At this stage, we are only focusing on logic and circuit design. We're not worrying about the hardware details. Okay, and second step, now comes something like little bit powerful, like different hardware providers use slightly different formats, right? If we directly target each backend separately, it becomes complicated. So qBraid introduces SDK abstraction. What does this mean? Like it creates a uniform layer between your code and the hardware. Okay, think of it like a universal translator. No matter which SDK you use, qBraid converts it into a standardized internal representation, and this makes your code platform independent. Now, after abstraction, the next step is backend mapping. So, backend mapping means selecting the target hardware or simulator and translating your circuit into instructions, okay, and which is compatible with the hardware. So, different quantum processes have different qubit connectivity and different gate sets and different noise characteristics. So backend mapping ensures your circuit is compatible with the chosen systems. Okay. Now the runtime takes the control. Okay. So this runtime manages job submission, queue handling, and execution control, communication with hardware providers. Okay. Think of runtime as the traffic controller. It ensures that jobs are properly submitted and tracked, and it will give you the log files also. And then the job is executed either on a simulator or a real quantum processing unit. If hardware is busy, the job enters a queue. If simulator is available, execution is immediate. Finally, results are written, and these results are classical data, typically like measurement counts and probability distributions, histograms. So from user perspective, we will write the code and we will submit. The code will get executed and we will fetch the data for analyzing. But internally, abstraction and backend mapping makes everything seamless. Okay. So now let us look at the ecosystem of what qBraid actually integrates. Like this is where the strength of platform becomes clear. Okay, so quantum SDKs. qBraid supports multiple SDKs. This means you are not logged into one programming framework. Faculties can teach Qiskit-based examples and other SDK-based workflows also. Okay, and still you will be using the same platform here, but different SDKs. And simulator. So simulator allows safe experimentation, and student can test circuits without worrying about the hardware noise here. Okay, so this is ideal for classroom labs or assignments and concept validations. And another providence is quantum hardware. So qBraid provides access to multiple hardware providers. So this exposes students to real world quantum systems and hardware constraints and research level executions. So this is extremely important for higher education institutions, right? And programming language like Python based environment ensures ease of adoption, right? So Python is the easiest way of programming tool in current world when compared to the C, Java, right? So no new language barrier is used here, and this integrates smoothly with AI, ML, and data science curriculums also. Okay. So now let us clarify and like now let us carefully understand what actual happens when we run a quantum program. So this slide represents the complete life cycle of a quantum job, from writing code to seeing final results. Okay, even though it looks simple, internally many important processes are happening. Let us go through step by step. Okay, So first stage, where we will be writing the program and build the circuit. At the very beginning, we write a quantum program, and this is done using the Python inside the qBraid notebook environment. Okay, what are we actually writing here? We are creating a qubit, applying the gates, and designing the circuit structure, adding the measurement operations. So this stage is purely logical. We are defining the quantum algorithms in abstract form. At this stage, we are not thinking about the hardware, we are not thinking about any connectivity, and we are not thinking about noise. We are simply building the mathematical model of the circuit. Okay, so you can think of this step like designing a blueprint for a machine. Now, second step, that is now comes something very important, like the program we write in Python is not directly executable by the quantum hardware. Why? Because quantum processors do not understand the Python code. They understand low level quantum instructions, so the circuit must be converted. So this conversion step transforms high level Python circuit and like intermediate quantum representation and hardware compatible instructions. So this process may include translating gates and decomposing unsupported gates and mapping the logical qubits and physical qubits. After conversion, the circuit becomes the what we called as quantum job. Okay, a quantum job is like a simple packaged version of your circuit ready for the execution. And third step, submit job via qBraid access model. This is one of the most powerful parts of the workflow. Like when we submit the job, we are not sending it directly to the hardware. Instead, we send it through the qBraid access model. Okay, now what does this model do? It performs two critical tasks. Okay, like SDK abstraction and backend mapping. Let me explain both clearly. So, SDK abstraction means no matter which SDK you use to write your code, like Qiskit, Circuit, or others, qBraid standardizes it internally. And backend mapping means your logical circuits must be adapted to the target hardware, right? So why is this necessary? Because different quantum processors have different qubit layouts and different native gate sets and different connectivity constraints. So if your circuit uses a gates not supported directly by the hardware, qBraid decomposes them into supported gates. Okay, if two qubits are not directly connected, qBraid inserts swap gates, like swap operations automatically. This is extremely important and it removes the complexity from the users. Okay, so essentially, qBraid acts as an intelligent translator and optimizer. Now the job is ready for the execution. So Q or immediate execution is like at this stage, one of two things happens. Like if you selected a simulator, execution usually happens immediately. Okay, if you select a real hardware, your job may enter a queue. Why a queue? Because real quantum processes are shared resources, right? So multiple users across the world may be submitting the jobs. So jobs are scheduled based on availability. This is similar to submitting a print job in a shared printer lab. So if printer is free, immediate printing. If busy, it will be queued, right? So once the job reaches the front of the queue, the quantum processes will execute it. Okay. The hardware applies the pulses, evolves the qubit states, and performs the measurement, and then generates the classical measurement data. So step 5, that is result returned via access model. After execution, results are sent back, but they don't directly appear in your notebook immediately. Okay, so they first pass through the access model. Why? Because results may come in raw hardware format. Okay, the access model collects measurement counts and formats them and converts them into a Python readable structures and attaches the metadata. Okay, so again, abstraction simplifies the experience here. So last step, that is results visible in qBraid platform. Like finally, results are displayed in the platform itself. There you will be seeing measurement of in the form of histograms and probability distributions, raw counts, dictionaries, and execution details. Okay, so this is the stage where analysis begins. And remember something important, like quantum computing does not give a single deterministic output. It gives a probabilistic distributions. So when you see results like it will be 0 0, when I run the probability of 1,000 times, I'll get 0 0 occurred for 512 times and 1 1 occurred for 488 times. When you add this up, it will be a 1,000 probability. Okay, so that means the quantum states produced those outputs across multiple shots. Okay, from this distribution, we interpret the algorithm's behavior. And let me summarize this workflow in a simple manner. Okay, so firstly, what you will do, you will design the logic. Next, the platform translates it, and the backend adapts it. The processor will execute it. Later, the system returns you a statistical data, and you will be analyzing the result. So what is important here is separation of the responsibilities. Okay, you focus on algorithm design, like the platform handles the compatibility, optimization, scheduling, execution management, and result formatting. Okay, so this is what makes quantum computing accessible. So, as a faculty, this workflow is crucial to understand, because when students ask what happens when I press run, and you know how you now have a clear answers, right? Like it is not a magic, it is a structured pipeline. And yeah, so this entire slide represents the backbone of quantum cloud execution. And once you understand this pipeline, quantum computing stops being mysterious, okay, and starts becoming the systematic. So now we have spent sufficient time understanding the foundations. Like we discussed what quantum computing is, how qubits work, what quantum gates and circuits are, and how quantum jobs are executed, and how the qBraid platform manages abstraction and backend access. So far, everything have been conceptual. Now it is time to move forward, move from understanding to experience, right? So quantum computing cannot be fully understood through theory alone. It must be practiced. So, and that is exactly what we are going to do now. Like from this point onward, we are shifting to the hands-on mode. We will create an account in qBraid platform. Next, we will log in and access the workspace, and we will explore which quantum hardware backends are available, identify which simulators are accessible, and understand the programming environment, and then prepare to run our first quantum program. Okay, so what is important here is that we will not just see the simulation, we will actually explore real quantum processes that are accessible through the platform. Okay, so the difference between the simulator and hardware, like how backend selection works and how quantum jobs are submitted. So think of this as moving from a classroom discussion into a laboratory session. Until now, we were talking about how quantum systems behave, but from this moment, we will interact with them. Okay, so I request everyone to open your laptops. We will start by creating our accounts, and please follow the steps. Sorry. So please follow the steps carefully, and if you face any issues during the login or access, let me know immediately through the chat. Okay, so let us begin the practical session. I'll give 5 minutes time for everyone, like so that guys be ready with your Chrome browsers. Okay, so let's proceed and open your browser and type qBraid. Okay, just type qBraid. In Google Space, you will be getting a qBraid option. You can click on that, or you can just directly type qbraid.com. Okay, once you have typed this, click on login. Like if you already have an account, you can just click on login. Okay, or if you want to create the account, you can just click on sign in option. Okay, so sign up option. It is taking by default because I already have an account. So just go on creating your account by giving the necessary like credentials asked from it, like email IDs, password setups. Okay, so once you have done, just like ping in the chat that it is done. Okay, once your account creation is done. So I kindly request everyone to drop a chat whether to continue with it or you still need some time to create the account. Keep it interactive, okay? Because we are shifting for hands-on, so it will be not a board or tiresome, okay? Okay, let me answer your queries before we shift to the hands-on part. So any preamble coding is required for this? Yes, Python programming need to be required. And okay, sure, we will share the feedback link with you. And is qBraid freely accessible? Actually, you can use the platform, but if you want to use the quantum hardware to share the data, like if you want to run your programs in the hardware, you need to buy the credits. Okay, and if you want to increase the space also, you need to increase that. You need to buy that format. Because we need abstraction. Here we are not providing only access to single quantum computer. Okay, we are providing access to multiple quantum hardwares, so each will be working on different qubits, different number of qubits. So to make it understandable, qBraid will be using this abstraction layer to convert it in a understandable format for that. How to choose the access model? It is not a like you will be choosing the access model. It is already like uh, if for example if you are going to use the state vector simulator. Okay, so it is available only through the access model Amazon, so you need to select that state like access model itself. Okay, and okay, so completed login. You can see the dashboard after login. Okay, no, like it will be active for long time. Like it will not get expired or lapse back. You'll just need to create the account, and I'll just give you a coupon code. So like to access the credit points. Okay, so I'll just show you the process after the account is created. Okay, no, there is no time limit for the login ID. Okay, so if is there anyone like should create account? Kindly drop in chat like you need some time to create the account, like 5 minutes or something. And if you have completed, just drop it is completed, just to make sure everyone is on the line, on the same page. No, but I am able to see your replies here. Okay, let me check. Anup, can you check it once, like for attendees chat is disabled or not? Just give 5 minutes. Okay, so your query will be rectified. Okay. Okay, so it is in Q&A section. Fine. Okay, sure. So you just need to click on the login if you already created the account, okay? Or click on the sign up and give the wanted like email IDs and password, whatever it is asking, and create the account, okay? Okay, so everyone should be seeing this dashboard right now, okay? Yes, don't click on anything yet, okay? Just be on the dashboard itself till I give the instructions. Yes, so I will just walk you through how to access these things. Just wait patiently, like I'm waiting for everyone to finish creating the account. How should I log in? Like you just need to type in the browser qBraid.com, okay, and click on login if you already have a account, or click on sign up and give the necessary credentials, okay, and create one account. Okay, fine. I guess almost everyone's is done, right? I'll give 5 more minutes. Like if you are still facing any issues in creating the account, just drop a message like facing issues or need some time. Okay. From scratch, I didn't understand. Like for documentation on what process, ma'am? like the hands-on things, right? Yeah, sure. Sure, sir. Okay, let's proceed with the next step. Fine. Okay, so everyone is in this dashboard, right? Now let's get some credit points. Okay, so go scroll down and you will get this wallet options on your left side. Okay, everyone can see this. And here, when you go down, you will get custom credits. Okay, so here you add $5. Okay, are you able to see this custom option? Here you should enter $5. Okay, and click on the purchase option. Okay, so once you clicked on that, you would have navigated here. Don't do any changes here, you just click on the add promotion code. Okay, so here you need to add this code I'm sharing in the chat. Okay, so add this code in that promotion code. And once you have added it, click on apply, and you should see your cost is getting reduced to 0. Okay, and once it is done, click on complete order. Okay, so once you have clicked on purchase, here you need to see 500 credits in your wallet. Okay, just let me know in chat like you got all the credits or you have stuck in between somewhere. Kindly scroll down, ma'am, like on the left hand side. Okay, here you will be seeing the dashboard option, device, jobs, AI, and in this account, okay, it would have been like you need to expand this account tab. Here you will get the wallet option. Click on this wallet option and you can do it. Okay, so once you are in the dashboard after the login, go to the wallet option. Okay, and here you will get the custom option. Fine, in this custom option you just need to give $5. Okay, once it is done, click on purchase and click on add promotion code and add this code which I have shared in the chat, FTP 2026. Okay, once you have added that code and when you click on apply, it should show 0 rupees. Okay, no costing value will be there. Once you do that, click on complete order. Once you click on that, you should see 500 credits got added to your account. Okay, I hope Once you click on the purchase option, you will be navigated to the place where you will get the promotion code option. There you need to add it. Okay. Okay. Yes. Here in the custom option, you need to type it. 5. Only 5 you need to type. Okay. Don't give dollar option like dollar symbol and all. Just type 5 and click on purchase. Promotion code is like a vouchers we are going to give you, right? Okay, for 500 credits, since this is an FDP, that is FDP capital and 2026. Okay. Yeah, Shri Haripriya ma'am, you got the credits with promo code. So now if I'm teaching in my class, can I use the same promo code for them? Actually, no, ma'am. This is only designed for the FDP purpose. That's it. So it will get expired later. Umesh, done. Okay, good. And Hamil, yes, done. So if you are stuck somewhere, kindly drop it. Actually, the accounts which you are using now, it will be active till you use it of 500, but the voucher code will be not active. But whatever credits you have got now, it will be active until you finish it off. So you can use that credit points. But voucher codes will not be active. Okay. Share Priya. Okay, if I would like to work later after 10 days, how can I work? So, as I said, your credit points will not be expired. Okay, you will be having that credit points. You can use that. Yashasvi credit done. Okay, Nandita added. Okay. So, if you want to teach your students, ma'am, you can show it from your account how it is working. But if you want credit point access for your students, later we can like Digitoad, you can reach out to Digitoad. We will provide you the bundle where we will provide credit points based on the number of users you are going to access for. Okay, Vinod, done. Any free options for at least the basic concepts? No, ma'am, actually, no. For credit points, you need to buy the credits and then you need to use it. Done. Okay. So yeah, I'll show it once everyone is ready with the credit points. So we'll proceed at sharp 3:30. Okay. Actually, there is no limitations like lifespan for the credit points, ma'am. You can use it for months. Shri Haripriya, ma'am, I hope your query got solved. Like there is no lifespan for your credits. It will be there until you are going to use it fully. Okay. No, no expiry for the 500 credits. You can use it for your experimentations. So credit points are calculated. Yeah, Senthil Nathan sir. Credit points are for running your circuits in the hardware or simulator, like quantum computers or simulators. Okay, so it depends on the type of computer you are using or type of simulator you are going to use. Different will have different credit access, like credit scores. So it will get decreased based on that. Ranjan Bala, for one experiment, how many credits are used? It is not like it is designed for a specific experiment. It is for the quantum computers access. Which computer you are going to access, or which quantum simulator you are going to access. Those cost. Okay. So I hope everyone got the credit access. I'll proceed with the next step, like launching the labs. Okay. So before launching the labs, let's go through the dashboard here. Okay. So here, when you navigate to the device options, okay, so here you will get all the information about the devices, which and all you will get access to. Total number of devices are 34, and in that, 23 are real quantum computers and 11 are simulators. Okay, in this, how many are online? That value also will get it here. Okay, like 28 devices are online. And here you will get all the properties about the device itself, like about AQT device, like how many qubits are there, and Q is there, like any what do you say? uh, uh, any person, like other persons, if they are working on this similar hardware, your like job will be queued, right? So before executing, if you want to check how many queues are present, you can check it here. And the price, right? So for this one, it will be showing here. Okay, like for number of shots, how many like how much credits it uses for per shot, or per execution times, or per minute. Okay. So similarly, like this, we have information for about all the devices, and this is a simulators from Amazon Web Service. Okay, and we will see a demo on SV1, that is a state vector simulator, and we will be using through the Amazon Bracket. Okay, so this one is also a pricing, like it will show you how many qubits it has, and like Q, and the price for it. Fine. Here this price is not like the shorts price. Okay, it is for like booking price. And these are some quantum computers from the IBM, like they have different quantum computers, and which have different number of qubits. And here you can see still in Kingston, they have still 218 jobs in the queue, so it might take time when you are executing the circuits in this. Okay, and similarly here IQM we have. Fine. So you will be having all the information about what is the hardwares available, simulators available, and what is the qubits they are using, how many number of qubits they are using, Q's values and pricing, everything will be available here. And the highest number of qubits which is available in this is for Quera. Okay, so it has 252 qubits. Okay, and yeah, so here you will get all the details about the quantum like computers or simulators. Next, in jobs. Okay, so here I said you will build this circuit. When you saw in the workflow, you would have saw you will build the circuit, and then you will convert it into a job, and then you will be submitting it. So here you will get the like dashboard displaying what is the log files about your job, how many jobs you have executed, how much have been completed, and still something is running. Like if your job is queued, means it will be showing here. Okay, so everything will be showed here. Fine. And yeah, so API keys. Okay, so if you want to connect to any like as I said, in qbook you will be having the access to create your own course, and you can add your modules there. Okay, but how you will be submitting, you will be submitting through some GitHub platform or something, right? But to connect your GitHub to the back end of the qbook builder, you need to have the API keys. So those API keys can be here. And before launching the workspace, then that time also you need to create the API keys. So everyone navigate to this API keys now. Okay, click on create API key. Fine. Here you can give any name like FDP demo 2026 or anything you want. Fine. So once you create the key, you will get this API key. Okay. Just copy this one. Copy it and paste it somewhere where you can access it later. Fine. You need this while launching your workspace. Fine. Copy this API key and you can just click on close button, or you can just click on I have saved my API key. Okay. So once you have created the API key and you have saved it somewhere, go to the dashboard. Okay, so everyone will be having a doubt like, I'm going to run the program which is submitted to the quantum computer. So my laptop's processing power should be more. Like, what is the processing capacity my like laptop should have? So no need to worry about it because we are running it on the cloud. So we are running it on a instance. So here you can select the small 2V CPU 4 GB RAM. Okay, so once you have clicked on once you have selected that, click on open server. Mine is already running, so it is showing open running server, but you will get open server option. Fine, you can just click on skip tour. But here it will be asking the API keys, right? So if it is asking for API key, just paste the API key you have created before. And you will be having the Jupyter notebook access. Okay, so ensure everyone is on the same page. After saving the API keys, you just need to go to the devices like dashboard option. Okay, so here you need to go for the dashboard. Okay, select the instance and just click on open server. Once you have created the API key, copy that API key and store it somewhere, save it somewhere, okay, in your notebook or Word files or anywhere where you can access it later. Fine. And then go to the dashboard. Okay, and select this instance, that is small 2V CPU 4 GB RAM, and click on open server. And when you click on open server, it will ask for the API key, and paste the API key which you have created previously. So you will be seeing this Jupyter notebook. I hope, should I answer it again, or still you guys are how to generate the API key through Shita? So you just need to navigate down. Okay, here, if your account thing is not expanded, click on expanding it. After valid, you will be seeing the API key. Okay, so once you are clicked here, you can see the option of create API keys. Okay, and when you click on create API keys, you need to give the name for that. You can give anything, whatever you want. And when you click on create, you'll get the API keys, right? You just copy that and save it somewhere to use it later on your workspace. Fine. Once you have done that, just close this, go to the dashboard and click the select this instance, small 2V CPU, 4 GB RAM, and click on open server. And when you click on that, you will get a option to enter API key. So paste your API key option there, and you will be seeing your environment. Sure, Sindil Nathan sir, we will hold. Okay. Yeah, it will take some time to launch. It is for the first time. Let it. Yes, Asha ma'am, it will take some time. Wait patiently. Hold it there, ma'am. After giving the API keys, just click on launch. Don't select anything there. Just click on launch and launch your Jupyter notebook and keep it there. Okay, so Sindil Nathan sir, after that we have to choose console or notebook. So there you need to choose the notebook. Okay, so once you have given the API keys, you need to see, now you can see the option called as Jupyter notebook or console, right? There you need to select the Jupyter notebook. So Ashwita, in the notebooks, which one should I select? Yeah, we will move on to the add environment part later. Okay, just open the empty. Yes, it opened empty IPYNB file. Yes, it is correct, Yashasvi ma'am. So after the job submission of key, I am getting launcher. What to select there? There, Ranjan, you need to select the Jupyter notebook. Dilnathan sir and ma'am, this credit will be debited from us only when we try to use, yes, phantom processes as well as simulators. Trishita, what to select in Jupyter Notebook? You just click on the Jupyter Notebook. You will be seeing one empty IPYNB file got opened, or you will be in this environment. Like empty files will be there. Here I have created the files and folders, so it is showing these options for me. Ranjan, in Notebook I have Python 3, no Jupyter Notebook. No, you should be able to see the Jupyter Notebook option. Okay, I'll just use my qBraid. Okay, so once I click on qBraid, I'll get this option and I'll just click on sign up. This one I'll do with my personal account. Okay, so Okay, I'll just create the password. Fine, I'll just click on create account. Okay, let me verify the mail ID. Okay, so let me sign in. Okay, so first step was I'll just expand my account tab and I'll go to the wallet. Okay, I'll just create 5 credits and I'll click on purchase. And here I'll add my promotional code FTP 2026 and I'll click on apply. Okay, I'll just skip this step because everyone have done this step. Let me just show the launch lab. Okay, just go to the dashboard and I'll select this instance and I'll just click on launch new instance. Let the server state get started. So let me just click on skip tour. I think everyone is on this page now, right? Your notebook have been launched. Okay. So does anyone stuck somewhere in launching the notebook? Okay, fine. Okay, then once you have done this part, you can take a 10 minutes break. Okay, we will come back shortly by 4 5. Fine, and we will execute our programs and by creating the environment. Okay, so we'll pause the session for 15 minutes. Fine. No, mine it as like I did not create the API key, but when I clicked on the Sindhil Kumaran sir, it's for you. Like when I clicked on launch instance, it itself created the API key because I forgot to create. So I gave create the API key by itself, and later I copied the API keys, if you saw that step. Okay, then fine. Let's start with creating the environment. Okay, so if everyone is in this tab and if you are seeing this option, if you are not, you can just click on this env. Okay, so you will get this option. Fine. And here you need to click on add. Okay, so click on create environment, and here you can give name as FDP demo. Okay, so and you can describe about this environment. And here I can enter tag FD. Okay, and you can click on create. Okay, so are you able to see this step here? Okay, once you got this, click on more. Okay, and here in packages, click on add package. Okay, and here you need to select qBraid and click on this any, and make sure to select the version of 0.11.0. Okay, version 0.11.0. Fine. And click on add. Okay, Suresh, I'll repeat the step for Suresh, Vinita, and Raghavendran. Uh, Sri Lakshmi, so tag you can give like FDP or something, whatever you want, just to describe your environment. Okay. So once you have given that, I'll just repeat the step again. Okay. So you need to click on this environment. If it is not visible, here you can see ENVs, right? Just click on that. Your environment tab will get opened or expanded. Click on add. Okay. And here you need to create environment. And here you need to give the name and some description about your environment. Okay, and tag you can just type like FDP or something. Okay, once you have given that, click on create. Fine. Once you have created the environment, okay, so you will be having this now. Like here you will be having your environment name with 30 packages or something. Okay, you need to click on more, and here click on add a package. Okay, and here you need to type qBraid. Fine. And here you can see next to qBraid any option. Here you need to select the version of 0.11.0. Okay. And once you have selected that, click on add option. Okay. Once you have done this step, so I hope everyone have created this step. Okay. And here, when you click on new file, okay, you create a new file. Like you can click on this Python 3 FTP demo. Okay, your IPYNB file will get opened. Fine. So here you can see three dots, right? And here you need to select the environment. Okay, so you need to click on this and make sure your environment is Python 3 FTP demo. Fine. Not a default Python 3. Fine. Once you have selected this, okay, you can just rename this file as whichever you want, first demo or first file, like a file name. Okay, can just rename and keep. So everyone is on the same page, like created the file for your hands-on experiment. So Raghavendran sir, qBraid version number 0.11.1. I'll just open it again. Okay, so here you can just click on add package and you can just go to qBraid. Click on any and here you can see 0.11.0. This one. Okay, you need to select that one. Okay, Shri Haripriya ma'am, let it get created. So Bhuvaneshwari ma'am, I have repeated the steps. Do you still need me to repeat the step again? Okay, Shri Haripriya ma'am, thank you for answering. Okay, okay ma'am, I'll just repeat the steps, Bhuvaneshwari ma'am. So if you are not able to see this environmental tab here, you can just go for ENVs. Okay, click on add, click on create environment. Fine. Here you can give a name for your environments like FTP demo or something. Okay, and here you can describe about your environment. Okay, and here you can give tag like FTP and click on enter. Okay, and then click on create. Fine. So once you click on create, I'll just not create this one because I have already created. You will be navigated to this pane. Okay. So here you will be seeing the options called more. Okay. And here you need to click on add a package. And here select qBraid. We need to install the qBraid SDKs for accessing the simulators or hardware, quantum computers. Okay. So and here click on any, you will be having the any option here. You can just click like this, it will be, and click on this drop down, and here you need to select the version 0.11.0. Okay, if you select any other version it will not work because like qBraid environment, they have just like updated the versions. So just select the 0.11.0. Okay. Once you have selected 0.11.0, click on this add and you can just close. So you can see your packages have got updated. Fine. So everyone's done. Everyone is on this page. Like everyone is ready with their new file. Just click on like drop a chat saying yes. File got created. Or is someone stuck somewhere? So I need to repeat it again. Yes, Umesh sir, recording for this session will be available. It will be shared after the webinar through the registered mail ID. Okay. Vinuta ma'am, version, it will be there like 0.11.0. Kindly check it again. Uh, Shri Haripriya ma'am, no need to remove the kernel now. Okay. Yes, Python, you don't need to do any other changes. You just need to select the qBraid version. That's it. Raghavendran sir. How to rename the file? You can just click on Control S. Okay. So once you click on Control S, you will just get an option for renaming it, or you can just right click on the file and here rename option will be there. Ashwita, I guess it got answered. Okay, Bhuneshwari ma'am, thank you for confirming. Is anyone stuck somewhere? Kindly let me know. After adding the version, yeah, I'll just repeat it. Okay, so everyone have created it, right? So let's, okay, once you have added the environment, you just need to go to your IPYNB file. Okay, click on these three dots, and here you might have Python default. Okay, this one, but you need to select Python 3 FDP demo. Okay, and click on select. So everyone have selected the environments. Okay, so let's move further. Now let's check whether we have installed the correct qBraid version. You can just import the qBraid. Just follow the coding according like with me itself. Okay, so we need to finish. We can finish fastly and we can cover more experiments. Okay, and let's check the qBraid version. And I'll just click Shift Enter to run it. Okay, sorry. Okay, so everyone is getting this here. Sendil Kumar sir, yeah, you need to select the environment. Like once you select your file, like when you open your file, here you will be having these three dots. You need to select the environment because here you have installed your qBraid. In Python default, you will be not having. Okay, so you need to select the FDP demo environment, like whichever environment name you have given, you need to select that one and click on select. That's it. And you can just close it and you can check whether your qBraid version is installed or not by programming it. Okay, so fine. Now just kindly follow with me. Now we need to install the packages. Okay, so just write this syntax. Okay, pip install qBraid version 0.11.0 and click on shift enter. I'll just share this in the chat. Okay, so everyone, thank you, Prajwal. Okay, I hope everyone's package got installed. Okay, next what you need to do is you need to restart the kernel. Just click on this refresh option available here. Okay, you can just click on this and click on restart. Maybe you would have, Ranjan sir, maybe you would have given space after percentage. Kindly check the syntax properly. Just copy paste the syntax I have shared in that. Okay, Sri Lakshmi, this is the button, like refresh button you have, right? This is the button to restart the kernel. Okay, sure, ma'am. No issues with the Python version. Okay, so once you have restarted the kernel, fine. Let's proceed with the actual hands-on part now. Okay, let's list out which and all is available for the runtime, which providers are available. Okay, so just follow with me from qBraid for runtime, import qBraid provider, and let's print it. Devices. Escape, shift, enter. Okay, so we have restarted the kernel, right? Just need to run this import qBraid again. Okay, so then you can run this and this. Oh, oh, yeah. So you can ignore these warnings. Okay, I'll just share this syntax. Okay, once you have ran this syntax, you'll get this providers list. Okay, okay, so now let's select the simulator which we are going to use. I'll be using the state vector simulator from AWS, that is SV1. Just click on, I'll type the syntax, AWS simulator variable I'll create, and from provider list, I'll just add the device here. And inside this, here you can see the device options, right? So here you need to search for SV1 So here you need to expand this. Here you will get the device ID. Just copy it and use the double inverted commas. Inside that, write this ID. Okay. And later we'll print it. Okay. So my simulator is available for the runtime. So I'll just proceed with checking its target specifications. So AWS simulator dot underscore. If you are not able to follow the steps, no worries. We will share the recording also. Okay. So these are the specifications. So I need to like access this through the Amazon bracket. Fine. So now let's build the circuit. Okay. So firstly, we will be building it using the circ framework. Okay. For that, we need to import. Sorry, we will build with Qiskit framework. Okay. So for that, we need to import the Qiskit framework. So type from Qiskit import quantum circuit. Now let's create the two qubit quantum circuit with two classical bits for measurement. Okay. So Qiskit underscore QC. Here we are initializing the qubits. Okay. So quantum circuit 2 qubits. Fine. Now we need to create the superposition state. So here we are going to build the Bell circuit. Bell circuit is nothing but you want two qubits to be appearing in the same state, like 0 0 or 1 1 only, and you will be measuring that states only. So to create that Bell circuit, firstly we need to apply the Hadamard gate. Okay. So we have initialized the qubit. Next we will proceed with applying the Hadamard gate on that is the dot h and on 0. So once I apply this, okay, next I want to apply the c naught gate. Okay, so c naught gate will make sure my bit, like if the qubit is in 0, if it is 0 1 or 1 0, if the control bit is 0, it will flip my next bit to, it will not flip anything. And if my control bit is 1, it will flip the qubit. Okay, it will make that qubit forcefully to come to one state. Okay, so Qiskit QC dot, I'll just apply the C naught gate here, comma 1. Okay, and I will measure it. Okay, so once you have written this state, fine, I'll just click on shift enter and I'll print the circuit now. Fine, so print, I'll write my variable. So you need to get this Bell circuit now. Fine. So now what I'll do, I'll just run this circuit inside a simulator. Before running it, I need to create a job ID and I need to run it, right? And I need to decide the number of shots I'm going to run. Okay. So I'll just create variable job is equals to AWS simulator dot run. I'll define my variable here, skip QC, and number of shots I'm going to run here is 1000, because since it is a simulator, I don't think so it will take more credits. Fine. And I'll print the job result. Just print the job result. Here I'm not getting values because this account doesn't have the, what you'll say, credit access. Fine. Count. I'll just show it from my account, company account. Okay. So let me just restart the kernel here. Fine, I'll run this. This part is done. Next, this is provider list. And here you need to get device runtime. Okay. So target specifications you'll get. And yeah, we are in this step. We have created the bell circuit, right? So yeah, so you will be in this step now. Fine. Once you have run this one, Qiskit, I need to run this one first. Just restart it. Just run this kernel input. Fine. I'll just go back and run my circuit. This is using circ, but we are building using Qiskit. Right. So yeah. So circuit is built. Now when I run this job, before running it, I'll just open this tab and I'll keep. When I run this job, just a minute, I'm just facing some issues here. Clear these tabs. Okay. So let me run this. Okay, provider I didn't run. So let me run this and this, and now I will run this. So it is available for the runtime. Next, let me check the specs. Yes, it is giving. And I'll not run this pip install again because it is already installed. Okay. Let me just delete this unwanted columns. Just delete this one too. And this one too. Okay. So let me run this circuit. Let me print this one again. Okay, so it is printing. Let me open this job and keep. And now I'll run this tab. So here my job will get updated. Okay, so I hope everyone got this output. Like you will get the ratio. You have ran the 1,000 shots, right? So for 1,000 shots, I got 1 for 500 times and 0 for 500 times. It might differ for a person to person. Okay, so check it out. I hope everyone got this output. Just type like you are on the same page. Yes, you can just type yes. Okay, I guess no response. Fine, I'll just proceed. Sure, sir, like if you want, you can just see the steps. That's enough. I will share you the coding file later so that you can use that and you can implement it. Okay. So similarly, okay, so most of them are just observing. I think it is difficult for you to observe and implement at the same time. Okay, we'll do one thing. You can just observe it here how I am doing. Okay, later we will be providing you this IPYNB file and the recorded video. Okay, you can implement it using your accounts. Fine. So here, similarly, I'll be using instead of simulator, I'm using the hardware that is Rigetti Anka 3. Okay, similar device ID, I'll just copy it from here. I'll go to device and I'll just click on this Rigetti Anka 3 and here I'll get the device ID and I'll paste it inside my variable. Okay, I'll check whether it is available for the runtime. If it is available, I'll proceed or you can use any other different hardwares which is available. Fine, and you need to do the same step. You just need to select the device ID. Okay, and once you have checked that, you just need to check the property. If you want to check the properties of it, you can just click on anchor device.metadata, which you saw it in the dashboard. Here you will get all the data like whether it is a simulator. No, so it is giving false, and number of qubits is 82, which is available inside this, and the provider is Rigetti. Okay, so this is the pricing for the credits. Okay, so this device will take 30 credits per task. Okay, and per shot it will take 0.09. Fine, so I'll just use 50 shots for this and I'll just create one job ID and I will deploy it in the hardware, and when I print the result it will give entire log files, but I want only measured data. So I'll just print the measured data here. But here you can see that I'm not getting only 1 and 0 0. I'm getting the other value which I did not define only. Why? Because this is because of the qubits noise. Okay, so this is the difference between simulator as well as quantum computers. When you're deploying it inside a quantum computers, you will be getting the noisy values. Okay, so similarly for I have deployed in IQM Garnet also, same circuit which I have developed using the Qiskit. I'm deploying the same circuit inside the AWS, inside the Rigetti Anka tree, and IQM Garnet. Okay, so I'm just deploying it in the different hardwares as well as simulators, and here also I'm getting the noisy values, right? So you can see the noisy values here. Why? Because it is because of qubits non-static state. It is not because of your program error. Okay, so that concludes our hands-on session. And at the end of the session, I'll just say share you the IPYNB file also and recorded video of this FDP. If you have any queries, you can just let me know in the chat box. Sure, ma'am. We will share you the entire IPYNB files. No issues. Yes, Sandil Kumaran sir, it requires more patience to learn it. So since you learned the concept, I think if I share the IPYNB file, it will be easy for you to. Why choosing AWS then purpose of creating the job? As I said, why we are using AWS, because it is one of the simulator provider, and purpose of creating the job here is because whenever we are, I said in the previous slides, right, we are creating the jobs because it will be submitted in the queued format. Okay, so we need to create the job and we need to submit. Umesh sir, thank you very much for this answer. And yeah, grateful for that, sir. Raghavendran, sir. Yeah, thank you. Thank you, sir. Okay, let me just proceed with the slides. Then- So now that you have experienced the hands-on sessions and seen how quantum programs are executed in real time, right? So let me briefly explain how Digitode supports institutions in building sustainable quantum ecosystems. So at Digitode, our role is not limited to providing access to the platforms. We focus on five core pillars like enable, design, integrate, support, and scale. I'm sorry. Okay. So we enable institutions to start the quantum labs without infrastructure barriers. Okay. And we design customized quantum lab solutions based on like curriculum needs or academic level and research focus. Okay. Yeah. So, research focus areas and institutional goals, whether it is an introductory lab or advanced research programs, we tailor it for you. Okay. And we integrate quantum computing into existing departments like computer science, electronics, physics, AI, and ML, and cybersecurity also. And quantum does not stand alone, it enhances like existing disciplines, right? So, and we provide continuous academic and technical supports also, like FDPs, SDPs, and workshops and curriculum mappings also. And we ensure it is a long term success. Okay. And finally, we help institutions scale from small teaching lab to a full fledged grade quantum centers. Okay. So yeah. Yep. So let me briefly explain what we mean when we say we support teaching labs, certification programs, and all. Okay, when we say teaching labs, we mean structured, like curriculum aligned lab environments that faculties can directly integrate into semester courses. Okay, so faculty do not need to build lab from scratch. We provide academic ready modules that align with undergraduate courses, postgraduate electives also, and interdisciplinary programs. Okay, talking about certification programs, they are designed to build a structured competency. Okay, so these can be short-term skill certifications and value-added courses as well, and industry-aligned certification modules, and add-on programs like beyond regular curriculums. Okay, here students will receive hands-on exposure and practical evaluation and certification upon the completion of the courses. Talking about FTPs, so faculty enablement is the backbone of sustainable, right? Like technology, for the technology adoption. So through FDPs, we provide concept clarity, hands-on training, as well as curriculum mapping guidance and teaching methodology support, as well research direction insights. Okay, so the idea is not just to train faculty once, but to empower them to independently deliver quantum courses to the students. Is so we actively support student innovations also, that is for student projects. This includes like mini projects, final year projects. Okay, and we provide a problem statements and technical mentorship, platform access, and guidance for implementations also. So students can work on different labs like quantum algorithms, quantum cryptography, and hybrid quantum classical models, okay, and quantum machine learnings. Fine. Talking about research collaboration for institutions aiming at advanced research, like we support collaborative initiatives. Okay, so this may include research grade backend access, like if you want to book the specific hardware for specific time, that is also that also can be done. That pricing you can see it in the website itself. Okay. Uh, so when we say we support institutions, we do not mean like just software access. We support the entire academic life cycles, like from classroom teachings to certification programs, right? So we offer these lab programs in 4 different formats. Like we provide in quantum teaching lab, next is quantum cryptography lab, next is quantum science lab, and quantum machine learning lab. Teaching lab is for a starter package, like from basics of building the quantum gates to the like building quantum circuits using the gates. Cryptography lab is about building the protocols like BB84 protocols, Groover's algorithms, right? And quantum science lab is about studying the state of the qubits. Okay, so different experiments will be available for different labs. So quantum machine learning will be on the ML based. Fine. So if you guys have any queries, okay, so before we conclude, I'll be happy to any questions, technical, academic, or integration related. Please feel free to ask. We would be glad to clarify. Shri Priya ma'am, how much cost of credits will be used if we use AWS? How much credits will be used for simple circuits in the IBM? Okay, so likewise with other providers, right? So you can just go to the qBraid website. Okay, there you'll be having a documentation option. Fine, you can just go through that. I'll just share the link also. Here you will get option. You can just search here, okay, for different simulators, you will get it. I'll share it for everyone. Thank you, Raghavendran sir. If an institution reaches out to you, will you give a presentation to the people that matter? Yes, sir, sure. As an initial conversation, we will be providing the PPT presentation explaining about all the solutions. So, Rohit, what is the highlights for tomorrow's session? So tomorrow's session is all about like as I said, you will be getting access to the qbook courses, right? So when as a researcher or a professor, you will be having your own course built for your students and you want them to access it. So tomorrow's it will be all about qbooks and qbooks builders, like how to create the courses there. Okay, and what are the courses available, what are the modules available inside that, how we are going to access it, what are the ready to circuit available inside each module. Everything will be explained by Harshit. Okay, so he is a quantum software engineer, he is from qBraid, so that resource person, he will be handling it tomorrow. Stanley. So we choose SP1 simulator. Which simulator should we choose? Is it based on the application we choose for QML, which is the no, it is not a simulator. See, when you are talking about quantum computers, it is designed for a general purpose. Okay, but while selecting the SDKs like Qiskit or Circ, for QML, you will be using the penny lane like SDKs. Just like that, your SDKs will differ, not the simulators or quantum computers. Shri Haripriya, ma'am, now I created an environment. Can I use the same when I work next time, or should I create? Shri Haripriya, ma'am, like you can use the same environment. You don't need to reinstall or recreate it again and again. Like why we are creating the environment, because you will be having different packages listed for different environments or different projects, right? So that time you will be working on that. Is digital technologies? No, Sri Lakshmi, ma'am, it is located in Bengaluru, Banaswadi. Yes, Sri Lakshmi, ma'am, you can use Penny Lane for QML. For every Sri Haripriya ma'am, like for every environment, you need to install the qBraid. If it is not present, you can just verify it by importing it inside the Jupyter notebook. Okay. So, any other questions? Thank you, ma'am. Thank you. Okay, I hope all the queries have been solved. So before we conclude, I would be happy to as we come to the end of the today's session, I would like to sincerely thank all of you for your time, engagement, and active participations. So your interest in quantum technologies reflects the forward-thinking vision of your institutions. Okay, so the quantum computing is not just an emerging topic; it is becoming a foundational technologies for advanced research, cybersecurity, AI acceleration, and national innovative initiatives. Okay, so institutions that adopt these quantum educations early will lead tomorrow's technology landscape. So at Digitodes, our mission is to bridge the gap between emerging technologies and the academic institutions. So beyond quantum computing, we also offer solution in AI/ML labs, 5G and wireless communication labs, as well as embedded systems and IoT labs, AGI platforms, FPGAs, and research grade test and measurement solutions. So we work closely with universities, engineering colleges, and research centers to build future ready labs. And if you are interested in setting up quantum lab like FDPs, customized training workshops, and research collaboration or complete technology lab ecosystem, we would be happy to connect. You can reach us through this like mail ID or through the contact number I have displayed here. Okay, and You can go through our website also at www.digitotech.com. So we are always available to discuss how we can support your institution's roadmap. Thank you once again for your valuable time. We look forward to collaborate with you. Thank you.
View. So if you can just say yes or no, so that'll be better for me.
Yes, Rashid, it is visible.
Yep. Okay, perfect. So, okay, I will start with a very brief overview of what qBraid is, what we do. Again, even though Govardhani gave a very good presentation yesterday, I'll just reiterate that because I don't think reiteration ever, does any wrong. So, what qBraid is, we're basically a one-stop quantum computing platform which provides access to different devices over the cloud, whether they are CPUs, GPUs, or quantum processing units. We aim to provide a single access point for all the quantum computing community at qBraid. Okay, so that is what we are. A little bit about the agenda. So we're going to be starting about what qBraid does, what are our verticals, and then diving into the challenges and needs of the quantum education sector, what they are actually. After that, we'll see what our education platform offers, and the name of that platform is QBook or Quantum Book, right? We'll see a demo about what the current courses are, how you can, interact with them, and how you can see, okay, which particular course you're enrolled in, and what the content looks like, how interactive they are. Then we'll digress a bit and see how you can build your own courses with qBook, right? And also deploy them to qBraid. We're going to have a session for that. And finally, we also have a CMS system built inside qBraid, which is allowing users to manage whatever students they want to enroll in their course, right? So with that, let's get started. And if you guys have any questions, feel free to unmute yourself and ask as well. Otherwise, if you can't, then please, I would say put it in the chat, and I think Anoop or any other person from Digitode will help us coordinate that, right? So with that, let's get started. Okay, so again, qBraid is a comprehensive quantum platform, which is built to help people get onboarded to quantum very quickly. We provide seamless access to CPUs, GPUs, and quantum processing units inside the cloud, right? And our aim is to commoditize access to quantum computing throughout the world. And we've tried to do that since 2020, and currently we're at 26,000 users. And we just aim to, build up from here. Finally, we also aim to simplify quantum education through our education initiatives, such as qBook, so that people who want to get into quantum or who are already into quantum and want to upskill, they can come to qBraid, use our qBook platform, get complete their courses and upskill themselves through certificates or interactive learning projects, right? So that is the primary aim of qBraid. We worked very hard to build a comprehensive quantum platform, but not only that, a premier platform dedicated for universities, right? Currently, as Govardhani might have mentioned yesterday, we have access to 20 plus or 24 plus quantum devices, which include simulators and emulators from different companies like AWS, IBM, Rigetti, IQM. And all of those devices are present on a single platform, which is called Q. We have an organization-based approach to handling users, right? So if you are, let's say, a company, you can create your own organization inside qBraid. Or let's say if you're a university and you want to create a lab, you can create your own lab organization inside qBraid to, distribute credits to users or to, manage different kinds of access tiers across your users. So that is the mindset that we've, built qBraid with. Finally, we've also built it to deploy and teach courses with our own in-house qBook builder. And for those of you who are familiar with Coursera, right, it is very similar to that interface, but it is very much tuned just for quantum, right? So that is the major goal of why we've built qBook and qBook builder. Okay, moving on. We also provide seamless access to all the processing units, whether it be CPUs, GPUs, or QPUs, right? And if you're, let's say, a professor or a university who are looking to get into quantum by providing labs inside your university or run courses through which are powered by qBraid, you can basically consult with our team to make sure that your university has the right hardware access, first of all, that is through quantum credits, right? And second, for the management features, we provide organization-based access. So if you're a university, we can create an organization for you, and then you can manage your users through that. All of this is going to be coming in our later demos, which we will have today. But I just wanted to give you guys a sneak peek right now. Moreover, you can manage user access inside those organizations by giving, a different number of credits to each and every user inside there, right? And not only that, you can basically assign seats to standard tier or access tier or pro tiers, which are present in the qBraid subscriptions, right? So that is also possible with the organizations feature. This is some statistics about qBraid. As I mentioned, we already have 26,000 users and counting. We also provide quantum software environments, which I think Govardhani explained very well yesterday about how you can use qBraid Lab to code right inside your cloud and submit and interface with different quantum systems, right? We also have different university license across the United States, which include Yale, MIT, Berkeley, and other universities. We also host hackathons such as the MIT IQAC, which recently concluded on 31st Jan, the NYUAD Quantum Hackathon, NYC Hack, and many more, right? This is just some numbers which validate our product. Now let's come to the challenges in quantum education. And before that, I'd like to pause for questions if there are any. I'll stop sharing my screen and pause for questions. Um, do we have any questions, guys?
No, Ashit, we are good to go.
Okay, perfect.
I think we can keep the Q&A
Yep,
session at the end of the
Okay. So at the end of every sub session?
yeah.
Okay, fair.
No, I said actually after the end of the session.
Okay, cool. No worries. Yeah.
Yeah.
Yeah, so I was trying to talk about the challenges which are present in current quantum education scenario, right? So some of these which I personally feel are relevant are first of all sustaining the student engagement, right? So for example, if you have people who are trickling in your quantum computing course, right? They have a lot of enthusiasm during the start of the, let's say, first week or the second week. But as and when the things start getting a little bit involved, they lose out on their, I would say enthusiasm, and they have a hard time maintaining attention and participation, right? That is one thing. Another thing is not having prior exposure to quantum systems or quantum computing, right? So many students feel that this is a very tough subject and we can't approach it directly, which is actually not true. Because if you think about the learn by doing model for education, if you start working out, in code, or if you have many very small examples which are coupled with the theory, right? Students can actually start learning better, right? So limited prior exposure is definitely a challenge which currently many students as well as teachers face while starting out labs in quantum or starting out courses in quantum, right? Another point which I also personally felt while I was in my undergraduate program, right, was tracking of student work and submissions, right? Because as far as I know, a lot of the coursework or a lot of the assignments have been digitized, right? But there are still a lot of colleges which still accept offline assignments or offline submissions from students. Tracking those submissions and tracking their progress and performance across multiple, I would say, courses across multiple labs is actually giving a very hard time to the teachers who are teaching that course, right? That is another challenge which people face. And besides that, last but not the least, which I feel is actually the most important while working in this field, is bridging the gap between theory and practice. So, say you're learning the linear algebra required for quantum, right? But you only learn the mathematics, but you don't know, okay, how to implement, let's say, a particular matrix multiplication in code, right? Or you don't have any prior exposure to coding. So, the theory which you have learned is actually good to understand things, but not really to build, right? With the AI boom, definitely that landscape has changed a lot. But unless and until you have some basic understanding of what how you can implement the theory into an actual product or practical code, right? It's very tough to, move from zero to one. Once you've learned the theory, how do you move on to, an actual job or an actual research work, right? So building on from these challenges, we have the needs inside this domain, which provide an effective quantum education to students as well as uh, allow the teachers to manage them very easily. So the first one is interactive learning environments, where students are able to explore concepts through live code and actual notebooks, which are present inside, let's say, inside their development environment or maybe on qBraid, right? Because learn by doing is at least a principle which I live by, wherein whenever you learn something, you try to implement something which is based on that learning. And once you get some validation, you can say, okay, I've learned this, right? So that is the first thing. Another thing which we feel is providing well-structured course content, right? Organizing theory, examples, and exercises inside a guided learning path is very important, right? Because that provides structure, and the student does not have to think about, okay, in what order do I learn or what hierarchy I learn for a particular course, right? They just need to focus on what they're learning, right? And the the structure of that course is provided by us or by you who are going to be using our tools to build this course, right? Finally, coming on to simulation tools. So since the field is still in the nascent stages, right, it's still building up, you need very quick response on anything that you're developing, right? So for example, if you're learning something and you develop, let's say, a code for running some algorithm, some quantum algorithm, say the Grover's algorithm, right? Um, Now you're trying to interface with an actual quantum system, which has queue lengths for different people who are submitting jobs to it, right? So it will be very hard for you to test out what you have built is correct or not if you try to interface directly with the hardware, right? Not only about the access time, but also the pricing. Currently, those devices are priced very high. And if we take an example of, IBM, it is in the thousands of dollars per minute of execution, right? Which is not accessible to students who are just starting out their journey. So I would say accessible simulation tools which allow experimentation without any dependency on hardware is very important, right? And finally, coming to the thing which I've been saying at the start of the presentation is the learn by doing approach, right? Once you're starting to learn something, reinforcing your understanding through hands-on activities, quizzes, practical exploration, code which is present directly embedded inside your course is very important, right? So these are the needs which we feel need to be, taken care of to overcome the challenges which people face in quantum education. And the solution That solution, according to us, is qBook, right? We've tried to simplify quantum education as much as possible, right? By building an interactive and flexible quantum education platform. So qBook allows both students as well as enterprise customers. It doesn't really matter if you're just if you're a student or a professor or, an employee from a university who's trying to upskill, or maybe even an institution who's trying to upskill their whole workforce, right? All of you can come to qBraid or to qBook to learn, to deploy courses, get certified, and also train your workforce, right? So this is the idea behind building qBook. Um, qBook will allow users to create fully featured courses with interactive widgets with Now, multiple choice questions, embedded videos such as YouTube lectures, right? Code snippets inside Jupyter notebooks, and much more, which you'll see in just a little bit. We also inside QBook provide direct integration with Jupyter Notebooks, right? So you can not only log into qBraid for accessing qBraid Lab, right? You can also log in to just go to QBook and start, doing your course, right? Users can basically log into qBraid Lab for experiments, and they can complete their courses on QBook. So it's a very good amalgamation of both things, wherein you can interface with actual systems on qBraid Lab, but learn on QBook, right? And we also have admin features for grading and management of users during the curriculum, which I'll show you in a bit. Now, enough talking. Let's go into a demo, right? One second. So I will again start from the qBraid account, right? And I will give a very brief overview of this account because I know Govardhani gave this overview yesterday as well. But just to reiterate, I'll give an overview for the people who were not able to join in yesterday. So this is the account.qbraid.com where you log in and you see a dashboard and you see a lot of features here. I'll go over them one by one. This dashboard allows you to launch the qBraid Lab. So what is qBraid Lab? That is lab instances or Jupyter Notebook instances in the cloud, right? So if you see, let's say, for example, this instance, it will provide you four virtual CPUs, 8 GB of RAM. And if you launch this, a new lab instance will come, right? Then you have some details about what quantum jobs you have executed on the platform, some helpful information about quick actions, and a usage overview, like how many hours did you execute your lab instance for, how much space you have left for your lab instance, and so on, right? Moving on to devices. So we also have a quantum devices panel inside qBraid account where you can see the access to different quantum devices present over qBraid. So as I showed you, right, we provide access to 24 plus quantum devices, and currently 26 are online. And out of those, 11 are simulators, right? Let's take an example of the IQM's device, say Garnet. So this device has 20 qubits, the gate model paradigm for this device, and the type of qubits is superconducting. Then we have different provider information. We have performance of how many current jobs are pending on this device, what's the pricing of this device, and how do you get started, right? Something like this. Now let's move on to the details of our jobs. So, for example, I submitted 15 jobs, so that's why I see them here. This was the total cost of my jobs. These are the details of the jobs which I've submitted over the last couple of days, right? And for example, you can see this particular job was having this ID. It was in the completed state. This was the device on which it executed on, the number of shots, and what is the cost of the device, and so on, right? Finally, we also have an AI assistant which can do a lot of things for you, but it can also, provide you question answers to different questions related to qBraid. It can also provide you a learning path for your quantum journey. And we also have an agent mode in which you can connect to your lab instance, right? And once you do, this agent mode will be able to do tasks for you. It not only provides you answers to questions, but also submits jobs to different devices directly to the chat interface. But that's not the topic of the day today. Today, the topic is qBook, right? So let's come to qBook. Right. So this is our interface on the account side of things, right? We have different types of courses available inside qBook. And for this introductory purposes, I'll shift to my default org so you can see it a little bit better. Second, let's refresh. Yeah. So these are the different courses which are present inside QBook, right? And for example, if we go to the Cube's beginner course, this is the beginner course which is present in Quantum, right? And this has different sections, and I'll explain a little bit what all of this means. So currently, all the users which are present on QBook on qBraid are enrolled in this course, right? We have different chapters and different checkpoints which you can complete, right? And these are the different details about that chapter. There are different number of quizzes present, right? And there are different videos present inside those sections as well, right? So let's go and see what this course looks like in Cubo, right? So let's launch it in Cubo. So let me move to light mode. So this is a notebook which we have for this particular introduction to quantum computing course, right? And as I told you, that this notebook is very interactive. We have widgets present here, right? Different types of widgets. We have uh, code sections present here in which you can directly run the code inside cloud, right? And it works out of the box, right? And similarly, you have different chapters present for different sections of this course. So you can also play these videos, right? Similarly, you also have different modules explaining different concepts. So for example, wave interference and quantum mechanics. You can also play around and have different embedded widgets present here. But not only that, you can also go and add quizzes to your students directly inside this platform, right? So, for example, I answered this question, right? Let's say if I want to take this particular question, what's the probability of getting exactly two heads, right? So, I think it's going to be 1/4 or 3/8, probably 3/8, right? Yeah. So you see, now this submission is going to be accepted in our admin management platform, right? And the instructor of this course will be able to see, okay, that I have submitted a response to this question, and they will be able to grade it as well, if they've not automatically graded, of course, right? Because this question was an MCQ, so it was automatically graded. Similarly, we also have very different chapters which, present you different types of code examples and background math, right? You can also submit something like this. So it's a 3, 4, 5 triangle, right? And we also have free response questions. So not only MCQs, but you can also, type your answer there, test, right? And you can also upload files to basically augment your answers, right? So for example, if you couldn't, type in everything, you could maybe do something on your own and then upload that file using a doc or something like that, right? So there's also an option to upload files regarding a free response question. And similarly, we have different types of questions which can be crossed over across different courses, right? And yeah, we have a very detailed course for introductory quantum computing and intermediate quantum computing, which takes students from zero to beginner and then further, which includes algorithms as well as basics of quantum mechanics as well as linear algebra. So this is like an offering which we're very proud of. And we can try to run some particular code or some particular videos, right? So, so one very good thing about this is that these videos can be customized according to whatever type of course you're running, right? So since these videos right now are only tuned for the beginner quantum computing course, right? If you have any other course present which you want to, let's say, deliver to students, you can have videos regarding that course, and those will be uploaded to your course, and that course will be present inside QBook, right? So I will show you how that's going to work out after this particular the first section of our presentation. So yeah. Yeah. I think Govardhani, I think I'd like to make it a little bit interactive because I've been speaking for the last 30 or 35 minutes. If people have any questions, they can, I think, ask right now because I can only, share my screen so much.
Yeah, sure,
If,
Harshit, you
yeah,
can
yeah,
do that. Yeah.
yep. So if anyone has any questions, how do you access this? That's a good question. You basically log into qBraid, right? You go to the Learn tab, Yashasvi, and then inside the Learn tab, you will see a lot of courses present, right? So you can click on the Cube's beginner course right here. Okay, one second, let me share again.
Yeah, you can share the screen and you can
Yeah,
show
I
that.
can share again. Yes. Yeah, so Yashasvi is asking how do we access QBook, right? So you first log into qBraid, okay? After that, you go into Learn, right? And then after that, you can access the courses which are present here. Does that answer your question? I think so. Okay. Bhuvaneshwari is asking, is this free? Yes, this is free. But we don't provide access to all of the content, right? Because the whole content is not free. You'll be getting something like one or two chapters at the start, right? But if you want to get certified, you'll have to buy some subscription on qBraid, right? But if you want to do this for a university, then maybe your university can get a license, right? So I hope that answers your question, Bhuvaneshwari. Then Ranjan is asking for the access of QBook, some credits are required, or anyone who has registered on qBraid can go through it. That's a very good question. So you can access QBook directly, but not all the courses are going to be fully unlocked for you, right? So what happens is that let's say you go to View More and you go to launch in qBook. So since I'm an admin of this organization, all these chapters are unlocked for me, right? But they might not be unlocked for you. I think the only chapters which will be unlocked for a free user are going to be the first and the second one, right? Others will be unlocked once you buy a subscription for qBraid. Yeah. Okay. I think that answers. Besides that, so for the new people who are joining in for the first time, if you guys want some free credits, we can give that to you as well. So what you guys should do is go on to qBraid, right? And you can do this right now as well. You go on to qBraid. Now then select account and then select wallet. All right. Finally, here enter $5 worth of credits. Okay. And then click on purchase. So what this will do is that this will redirect you to a Stripe payment link. And you can just enter FDP 2026 as the promo code, which we are giving you guys, and click on apply. So for those of you who have already redeemed this promo code, this will not work again, obviously. But for those of you who are new and they want some free qBraid credits, you can you can redeem this by clicking on complete order. So yeah, why it did not work for me? Because I already redeemed it yesterday. So if you have already redeemed it, it will not work for you. But if you have not, it will. Okay. And you can also see the transactions here. Okay. So this I already bought like 2 days ago. So that's why it's saying $5 credited. But yeah. All right, guys. Any questions for this redemption of the coupon code? If you have this, let me know. I don't see many questions regarding this, so that's gonna be fine, I think. All right. Yeah. Any more questions, guys? For now, for qBook or how many days this coupon will work? Okay, so this coupon is valid till I think end of today. You can redeem it by today. The credits which you get from this coupon they're going to be non-expiring. They will never expire. So you will always have those 500 credits until you use them, of course, right? So the credits will never expire. Then, all right. All right. Welcome, Pagadala. Right, building controls. All right. Yeah, so I would say if no more questions for now, we can maybe continue on to the next half or take a 5-minute break and then join in again. Is that fine, Govardhani or Anoop?
Yes, Harshit, we can do that.
Okay, so let's probably take like a 5 to 7 minute break and join it at maybe take a 10-minute break and join it at 2:50. Is that going to be fine?
Yeah,
Okay, so yeah, let's join in back in 2:50 and then we'll continue from there. Right.
sure.
Okay, perfect. Thank you, everyone. Yep. Okay. Hello, everyone. Welcome back. And now we're going to be starting with the second half of the demo. So let me just start sharing my screen, and I just hope you guys had a nice break. Start sharing my screen. I hope you all can see my screen, right?
Yes, Harshit.
Okay, perfect. Yeah. So we finished after having an overview of QBook, right? And what does a course look like on QBook, right? After that, let's start with how you can actually build these courses and what do these courses consist of in the first place, right? So the motivation behind QBook was again to modernize the teaching content which people use inside a university and making it digital and interactive. So all of you must be familiar with NPTEL, right? That is what the Indian government is doing for education, right? This is very similar to that, but this is tuned just for quantum, right? So what we have done is made QBook Course Builder to build either MCQ or free response questions and embed them inside a Jupyter notebook, right? So what you can do is you can use either pre-built questions across multiple courses, and then you can attach them to your notebooks, right? Not only that, any code snippets which are going to be present inside a Jupyter notebook, right? They will be directly run in the cloud and no setup will be needed just besides that you have an internet connection and a laptop. That's it, right? So there'll be no requirements of people needing a GPU or CPU or I would say QPU access, right? You can run all of this in the cloud and it will just run seamlessly, right? Besides that, you can also add interactive widgets and lecture videos as we just saw in the demo before this for each and every course chapter, right? Now, what does this actually look like in code, and how do you really build a chapter is what I will now demo for you. All right. So this is, a dummy course which I built over the course of like a couple of days, and this doesn't have, I would say, very comprehensive content, but this is just to, validate whatever we're saying here, right? So we have like a couple of sections, and Claude has also, given a very good overview for this. We have a couple of sections. Each section has two notebooks, right? And the content doesn't matter right now. What we're trying to understand is how all of this is arranged, right? So say you're a professor and you want to create a new course. So what will you do? You'll say, okay, a new course, right? And inside this new course, you'll create, let's say, chapter one, and then let's say chapter two. All right. Now, inside each chapter, you'll have section one dot IPyNB file. and section 2.ipyy5, right? So let's ask Claude to, generate some content for us. Hey, generate some generate a matrix multiplication tutorial inside section 1, chapter 1. So let's copy the path, which uses NumPy. Okay. So what I'm trying to tell you is how you build courses, right? So you could do this manually, you can ask AI to do it and then review your code, right? So this will generate a new file, and then what you do is that you include these files inside uh the course which is going to be published. So let me first show you what this course looks like actually published. So I ran this published course like a while ago, and it looks something like, oh, 1 second, just 1 second. Yep. Your work, ID, Delhi, please refresh once. Yeah. So this is what it looks like. This is like a very simple arrangement of two chapters. We have chapter 1, which is the introduction, and then we have chapter 2. Okay. Now, this is exactly replicated inside our code here as well. So let's say we see this, right? So we have section 1. Inside that, we have intro to QSIM, right? The quantum simulation, which is replicated here, right? Then we have introduction to quantum simulation. Introduction to quantum simulation is going to be present here, right? This one, all right. And then we have the setting up of your quantum simulation environment present in this. Got it. And similarly, we have chapter 2, right? So what this means is that every course is a collection of Jupyter notebooks. That is it, right? Now, what I told you, right? How are these arranged, right? So these are arranged by something like a JSON file. So what does JSON mean? So JSON is just a JavaScript object notation, and this is a way to arrange files inside, any particular text format, right? So this was the name of the course, right? Which is Quantum Chemistry FDP 2026 2, right? This was the description of the course that we're trying to add an introduction to quantum chemistry. The visibility was public. These were the tags. This was the image links, like whatever image you want for your course, right? And now we come to the main part, which is the content, right? So say you're a professor and you want to add two chapters, right? So you have the first chapter here, which is the quantum simulation tutorial. You add the file, which is the introduction of your chapter, right? Then you add the section pertaining to each and every chapter, right? So each chapter has, let's say, two sections. So we have section number 1 and section number 2. All right. Let me zoom in a little bit more. Okay. And you see that each chapter is associated with a chapter name, and each chapter has a kernel. So what does a kernel mean? So when we go to qBraid here, right, you see that this kernel, right, this is where your code executes whenever you run a particular code cell. So since right now I'm not having any code cells in this notebook, so we're not running anything here. But you saw in the beginning of the demo, right, we had a cube in the cube's beginner course, we had code cells. They were running through this kernel, right? And this is where your actual code or Python code runs. Okay, so we select a particular kernel name which is present in qBraid. Then inside a section, we basically replicate what we did for a chapter, but for a particular section, right? So let's take the example of the first chapter's first section. So we have chapter one, and then we're trying to include section one as intro to QSIM. Okay, this one, this notebook. We have the name of the file. We have again each section is associated with a kernel name and a kernel ID, right? Similarly for 1.2 as well, we have like a different file for the second section. Now let's move over to the second chapter. Again, we have another chapter and we have section for it as well. We have one section here and for the second chapter, right? So the second chapter will have section two, this particular file, right? And this is the intro for the chapter two. Okay. So this is how you now arrange your course, right? Um, any questions till now? I'll stop for questions. I don't see any questions, so that's fine. Let's move on. Right. Okay, so once we understood how we can, how we can arrange a particular course inside a repository, right? We will basically upload this repository to GitHub. Okay. Now your course will be living inside, let's say, this particular repository. So I named it new course deploy, right? And it has the right deploy.json file, which contains the structure of my course, right? And it also has the files inside this directory, right? So this is the path which I added inside my course.json file, which has the right paths for each and every chapter or each and every section, right? We also have some files regarding the images which are included, but that's not very important right now, right? Now, what you do is that this particular course JSON is then read by us and then published onto qBook. Okay, so let me give an overview of how that is done as well. Mm, Where were we? Yep. Okay, yeah. So this was just created right now, right? We can also try to create a new, course deploy.json right now. So let's do that together. Let's say we want to create course deploy new. Right. Let's give it a name, linear algebra. Linear algebra. It's going to be, oh, seconds. And what's happening? Sorry for that. And introduction to linear algebra for students, right? And if you want this course to be public, then you can set the visibility to public. Otherwise, if you want this to be private, then it is just going to be private, right? So linear algebra matrix, then vectors. Okay. Let's uh let's ignore the image links for now. They're not very important. And now let's go on to name one more chapter. So let's say matrices. Okay, the chapter name is going to be matrices. The chapter number is going to be one. And in the new course, let's say we have section one as matrix multiplication. Let's have section two as matrix addition. Now create a file for matrix addition as well. Okay, so we'll let it do that, and then we'll arrange the course deployments correctly. So the base file path for this particular deployment is going to be this section one. Or we can have an introduction as well. Let's say, let's have an introduction. Intro.ipy. Cool. So we already have introduction here, introduction.ipy. And introduction will just be, let's say, introduction to matrices, right? This file, this chapter introduces matrices and operations. Let's allow this, yes, their operations for students in the, let's say, CS 101 course or whatever. This is going to be our introduction, okay? So let's copy this, copy relative path, course apply new, current one, course apply new. Let's put it here, okay? Chapter file name is introduction.ipynb. We'll say qBraid Python as the kernel name. And then in the sections, we will add different sections pertaining to different chapters, right? We have NumPy, we have matrix addition. So let's actually switch these, right? We don't want matrix multiplication first. We need addition first. So now inside this, we'll basically add the section one and then section two, okay? So let's copy section one, get rid of that. Section name is going to be matrix additions. Cool. Chapter file name is section1.ipynb. Good. And similarly, we also have section number two. So let's edit this. Let's edit this as well. Section two. Right. So we have our simple chapter one, right? So for chapter two, let's have introduction to tensors, right? Tensors. So tensors are basically high dimensional matrices. Simple introduction to n tensor operation. Right? So let's add another file. That's the section one. Cool. And inside section one, let's add, okay, add the operations for tensor, inner product, and outer product. That's the file. What's the file? Oh, sorry. We'll change the model. Right. So again, what I'm trying to do is build a course hand by hand with you guys so that you understand, okay, what actually goes into building a course. And then once we've done that, we'll publish it. Okay. So yeah. Mhm, mhm, mhm. Let's also correctly edit the new chapter. Let it work, and till then we can edit it. Copy the letter that. We'll add this here. Then it's introduction. Okay. Then we have fundamentals of tensors, TensorFlow. Okay. Copy relative paths. Cool. And then we have chapter file name as section 1. Yep. So I think this is like a new course.json which we've built for, let's say, a new course for our students. So we have two chapters and we have uh, this new course deploy.json. Okay. Now let's also run those chapters locally first before we are publishing them, right? So this ran, this is running, this is running as well. Right. Test this. Okay, this is not running. No, this is saying that will get you a value error. It's fine. Yeah, so this is integer overflow. And then there's like an exercise. So you can basically add like a pre-response question as well inside your course, where you say, okay, I'm going to be adding a pre-response to this particular, exercise, and then people get submit the answer there and get graded, something like that. Let's also run this file for all. Right, all of them ran correctly. Cool. This will run. Let's run this as well. Yep, this looks fine. Right. Okay, great. So we have all the course sections and introductions running locally, right? And this course is done with these two chapters. Okay. Let's validate this course.json is fine. And yeah, this looks fine to me. Yep. Let's add it to a new branch. And now since we've added this to a new branch, we can add all the files in. All right, we can check it out. So all the files are now present, right? Now we can commit this, add new files to our for linear algebra course. Cool. And then we push it. What was the branch? Linear algebra course. Okay, great. So now we have the files here in new linear algebra. Okay. Now we'll push them, right? And then we'll see how it appears in QBook. So let's go to actions. Let's try to deploy the course. And of course, we have built the course deploy just now. There might be some, things which we missed. So there might be some failures in deployment which we'll have to fix definitely. But we'll try our best. Course deploy new, right? And we'll publish this, run workflow. So what we're doing right now is using GitHub to publish the course which we just built right now live, right? And once it is deployed in QBook, I'll show you how this action works and how, all of this works internally and how you can deploy your own course in qBraid. I think it's working fine. Yep, it's working fine. Great, it deployed. Nice. All right. Let's see that course in action now. See, we have this course appearing here, right? So this course was not present before we, logged into QBook. So let me see this course. Great. We have two sections as intended. We have first section, which is saying matrices, which has matrix additions and matrix multiplication. And then we have the fundamentals of tensor products, right? Let's launch this in QBook now. This is a very simple introduction, which I just gave. It doesn't have anything, so it's like rendering normally. And this is our introduction to matrix addition, right? So let's run this. This ran up. This ran, right? This is running correctly. And then we have matrix addition basics here. This will run as well. This will run. Similarly, this, right? Right. So this is, how you can, I would say not even in like what, 20 minutes, build a course in qBraid and deploy it to QBook and, just have it available for your students as well, right? So this is how seamless we've tried to make the whole interface. This is about the publishing of courses, right? And after this, we're going to be coming on to how you can evaluate student submissions and enroll students in this course, right? So I will stop here and stop for questions. And if you guys have any, I think you must have many questions. Okay, so Ranjan is asking, for creating a course on QBook, we should have organizational access, or I can create as an individual user. Yes, Ranjan, that's a great question. For creating a course, you need to be the organization admin inside a particular organization, right? So when I was inside the qBraid account, right? I was the organization admin of a particular organization, right? So since you must not have, a different organization rather than qBraid default, that's why you can't see it. So since this QBook builder and QBook deployments are a university level contract, we only give access to all of these features when once we are in contract with the university, or if We are working with a professor and their lab, right? So we can talk offline about what it means, to get access to QBook Builder and deploying courses on QBook. But right now, as an individual user, you can't deploy them. Yeah. I hope that answers your question. And you also asked that you don't find any QBook Builder icon. Yes, so you're not going to be seeing any QBook Builder icon because QBook Builder is basically just a GitHub action which runs, reads your course, and publishes it to qBraid's QBook, right? So that's why you don't see any QBook Builder action. Okay. Any more questions, guys? Mhm. All right, Arjun. Yeah. And if you're interested in, this feature, then definitely we should contact offline, or you can reach out to Digitord and any partner of Digitord who can, help you out. Any employee of Digitord. Yep. Mhm. Okay. No more questions here then. Perfect. I'll go back to my screen for sharing. All right. 1 second. Okay, so this was about how you develop courses with QBook Builder, and how you deploy them to qBraid. I will also give an explanation of what happened behind the scenes, right? When we were deploying. So let me go into. So this was the structure of the course organization in our repository, in our GitHub repository, right? And this is the action which we use to deploy the course, right? So this action is basically taking your qBraid credentials, which is the qBraid API key, reading your repository, right? And then publishing this course onto qBraid, right? I can show you the actions as well. So you go into deploy course and it'll have all the details. So first we get our upload action. So upload action is a piece of software which qBraid has built, which reads your repository, gets the course contents, gets all the images, all the links, verifies them, and then uploads them to qBraid platform. Okay. So this is how the deployment happens. We are deploying this course to qBraid, and this course processing is complete. And once that is done, you get a deployment summary which says that, hey, this is your course, this is your custom ID, and this is your qBook URL, which we can click and go. Oh, okay. That wasn't the right one. Oh, yeah, this needs to be updated. This needs to be double slash. Yeah. But you see that course here, right? So this is present. All right. And yeah, once you basically check out your action and you check out your repository, you deploy to qBraid using that action and the API key and the secret token, which reads your repository, right? Yeah, that was about it for how you build a course and then publish that course to qBraid. The next section, which I'm going to be talking about, is going to be how you manage users in qBraid and what is the the user management system looking like for people who submit any MCQ question responses or any free response questions, and how you build those questions as well. So that's going to be the next section. I will stop sharing and look for more questions. Individual subscriptions are also available. Yes, individual subscriptions are also available, but the pricing is going to be a little different. I can confirm and get back to you, Uma, for that. But we recommend going through a university or a company because generally this feature is costing a little bit on the higher side, not like the standard subscriptions. But I can confirm and get back to you. Mm. Yeah, so Sri Lakshmi, when you attempt that question and it says that you've run out of answers for the question, it means that you only have one attempt possible for that question. If you run it again, you'll not be able to, submit the answer again and again. It depends on what attempt limit the professor has set for that question. So if it is one, you'll only be able to answer it once. Right. Okay. And can you guys access QBook and look at the Cube's beginner, intermediate course and this quantum software engineering course? I'd love to know like your responses. Were you guys able to scroll through them, look through the content? You can answer you can post in the chat or in the Q&A session. Um, Okay, I'm assuming that you guys were able to log in, so that should be good. In the first attempt, that the status code 403. Hmm. Um, I mean, I am not really getting this, I think. Yeah, Sri Lakshmi, I don't think I'm getting that error. That might be an account issue. I can look into that like in detail. So what you can do is that you can go to qBraid account, right? And create a support ticket here. Okay, so you can add a subject and you can provide a description and then we'll look into it and get back to you, right? Mhm. Because that worked out for me right now, and that's why if it wasn't, then I might have had a solution. Okay, right. Thank you. You're welcome. Okay, so this part is done. I would again say let's take a 5 minute break and then reconvene, or maybe a 10 minute break and reconvene at 3:40. And we can then go over the student management platform that we have, which is called the QBook admin platform. And I can go over how you can, enroll students, manage students, provide them credits, provide them subscriptions, provide them seats, something like that, right? Is that going to be okay, Govardhani?
Yes, sir.
Okay, perfect. Yeah. All right, guys, let's meet at 3:40 again, and then we can start the next one. All right. Welcome back, everyone. I hope you had a good break again. And let's get started with the last section of our FTP, which is how you can manage students over over the QBook platform, and what does the organization feature look like for, any university or any professor or any lab, right? Govardhani, are we good to go?
Yes, sir. Sure. We can.
Okay, perfect. Yeah. Yeah, so we were just going through how we can publish the courses, right, through GitHub. So we saw that we can build the course content as Jupyter notebooks. Then we can use qBraid's course publish action to deploy that course for the qBraid organization. And then there was also one more feature which I can just tell you right now, which allows you to update your course. So it's like, for example, if you have any changes to the course, right, and you want to basically update your course. So what you can do is that we have a feature called the run mode. You can go to your course, go to actions, and then go to deploy course, run workflow. Right. So if you update the operation mode to update, right, whatever change you have in your course will get reflected in the QBook platform, right? And this is as simple as just updating your notebook inside your GitHub, committing it, and then after that, running this workflow with the update mode on, right? So it will not create a new course, it'll just update the existing one, right? That is about updating of your course contents. All right, let's start presenting. Finally, we come to how we can manage learners inside the qBraid environment, right? So we have like a complete student management system which is built within qBook, and you can use something like the qBook admin dashboard to first manage as well as grade student submissions within the qBook interface itself, right? So you can see insights about, different student submissions, student analytics, and also give out certificates to the learners who have completed this course, right? You can also add or remove students from the course via the organization member-based model, which I'll just, demo to you guys in a moment. On the left, you see the instructor dashboard interface. And what this has is like you have different students enrolled and how many questions they have answered so far, what's the average score of the students, and how many certificates you have issued to date, and so on and so forth, right? So let's see a demo for this as well, right? Let's go ahead and go to our QBook page. Let's first go to account and I'll show you guys what the organization feature looks like, right? So I'm in the qBraid default org, but for the purposes of the demo, let's move to this org. So this is the IIT Delhi Cubes course org, right? And inside this, we have the organizations feature in which I have members, okay? So what does this mean? So this means that if I have a qBraid user and I want to, and they're present in my organization, they're going to be present inside the organization member. So this is another account uh, of me on qBraid that's also present in this particular organization. And this is our COO, which is also present in this organization. So these, three members are present in this org, and different members can have different roles. So, for example, since I created this organization, I am the owner of the org, right? And Ricky is going to be the admin of the org, and there also are members in this organization, right? So you also see status here. So pending means that you sent an invite for the person to accept this organization, membership, but they haven't accepted it yet. That's why it's pending. And these two people have accepted it, so that's why they're active, right? Now let's go on to how you can invite them, how you can invite a new member, right? So you can invite the member by either through bulk invite, by basically uploading a CSV file of all the emails. Let's say you're a professor and you want to invite 30 students of your course. You just add a CSV here. We'll import all the names from there, and then you can just send a bulk invite, right? Or you can invite a single person. So, for example, I can invite this. This is one of my other emails, test invite, and this will be sent to my email, right? And then I'll be added to I'll be added as a member as and when I accept this invite, right? Similarly, you can also create an invite code. So you can create an invite code, for example, uh, get added to IIT the Cubes course, right? And you want, 10 people to use this code, right? And this expires in, let's say, 7 days. So we'll create a code, and then you can copy this link or you can copy this invite code link and then join this, right? So that's something that's very easy. You can just mail this link, or you can, send this link out in your class and something like that, right? And you'll see when the people start trickling into your organization. Okay. So this is about organization members and what does organization management look like. Then we also have billing pertaining to an organization. Okay. Now, there are two things involved here. One is the credit balance, which is present inside an organization, right? So, for example, this organization now has 800 credits. Now, what you can do, you can transfer these credits to any person inside that organization, right? So, for example, if I transfer some credits to myself, so for example, I say 50. So these credits are going to be transferred, 21, sorry, 50. Right. So I'll say transfer credits. What happened? Yeah. So I'll now get some credits after this. Right. See, that's now 1002. So this is a way to manage the total credit value provided to, let's say, your university or your lab, and then disseminating those credits across your users. So, some you can maybe give some students some more credits if they're, doing more experiments on qBraid, and you can keep your credits to yourself so that, you don't waste them to giving students who don't actually want to work or something like that, right? Not only this, you can also have a subscription, right? So what do I mean by subscription? Inside qBraid, we have different types of subscriptions. So we have the free subscription, the standard subscription, and the pro subscription, right? So now as an organization, you can buy a subscription which includes a number of seats. So, for example, you want to buy standard subscriptions and you want to buy five of them. So, these standard subscriptions are going to be just present for your organization. And then inside your organization, you can provide these subscriptions to different members, right? So, for example, if I have three people, I'll just buy three seats. Oh, sorry, three seats, right? And then there's going to be like $60 per month. And then these three seats can be given out to any person inside that organization, right? You can also buy this as an annual subscription, or you can buy pro subscriptions, right? Something like this. And you can also see a very verbose credit log or the audit log of what happened inside this org, right? So there was, a compute deduction for a person who was present in this org, right? And there was purchase happened. So we basically got 1000 credits and we transferred some credits, right? Something like that. And there was a person who basically executed a job in this organization and there was a job reduction transaction, so on and so forth, right? I will pause for questions here because this is, I think, an important feature to have. So I'll pause here right now. Any questions, anyone, regarding the organizations feature and the wallet feature? Why this is important? Because if you're a university or a professor and you want to, let's say, start a course, right? So all the students who are going to be present in that course are going to be enrolled in an organization. And that's why you need to understand, okay, how do you, give out qBraid credits to them? How do you give out seats to them, right? And then we'll see, okay, how these uh, organization members are actually related to the course, right? So if no questions, I'll go ahead. Okay, no questions. Perfect. Where were we? All right, so let's switch to our test organization. And yeah, now let's go to how you can manage, students in a particular organization, right? So let me go back to QBook. All right. So I am logged in as, myself inside QBook, and I'm in the default organization, and I want to manage students. So what do? I click on the admin dashboard, and this is what I see. So this is like an, instructor, I would say, consolidated view in which you can see, first of all your courses present. So, for example, let's go to this particular course, right? And you can see details about who has submitted, what particular thing and what is the overall total completion of the course. You can also see what is the question bank that you have that you can include in a different course, right? So, for example, you have this question, which is like a multiple choice question, and you maybe want to edit that question, or you maybe want to, use that question inside a course. So you can copy that question ID and then use that inside a course, right? For example, if I want to edit this, I can edit this as well, and I can write this as a free response question, right? I don't want to do that right now, but yeah, I have the ability to do that. And then inside this, you can also click on any particular student, like for example, Sarah Johnson, and then you can see, okay, what is the answer or what is the response of that particular student given a particular quiz or a particular course, right? So, for example, this particular student, Sarah, hasn't given any answer, so that's why their score is 0 right now. And you can provide overall, feedback. You can also check mark on whether you want to provide the issue, whether you want to provide the certificate of completion or not, and then submit, right? And grade that particular student. Now, there might be some students who have submitted something. So, for example, Michael, right? So you can see that what's the student answer for each and every question. And then given that you can, provide overall feedback, you can issue the certificate of completion here. And that's basically about it, how you can, manage students and how you can see what they have submitted to your course, right? The main thing about this is that this changes across different organizations. So currently, this is only loaded for default organization, and this is still in the works. We still have a lot to, work out here. But this is what the actual interface looks like. And why this is still in the works is because of the migration which happened for qBraid. I think you guys must be aware of the very big migration which just happened for the platform, right? So we're still migrating this admin dashboard completely. But the essence of this is basically allowing you to manage any student which is enrolled in your course and has submitted any kind of, answer or any kind of, pre-response question for your course. And then you can grade them and then submit out certificates, right? So I'll go back now. And did we have Curious. Yeah, and after the demo of the admin dashboard, I'd like to just highlight a little bit about the usage tiers. So we have different access tiers across qBraid, and we provide offerings from the free tier, standard tier, or pro tier plans. And we also provide the ability to buy quantum credits, right? So we provide higher usage tiers for cloud as well as AI if you buy the standard or the pro subscriptions, kind of like how people are doing for the AI models, like Claude or ChatGPT, and they're buying the pro plans and getting more usage. That's kind of similar for qBraid, but for cloud compute, AI usage, as well as for quantum compute access. So you can buy quantum credits for a pay-as-you-go basis. So, for example, if you want to run a job on IonQ devices, you can buy, $30 worth of quantum credits, and whenever you want to, submit your job, you can do that however you want, because these are non-expiring credits, right? Now, any university who wants to, let's say, publish a course or, let's say, have a contract for some particular duration for, let's say, a lab or a semester-wide course, so they'll be assigned an organization, right? And inside that organization, you will be having flexible tier seats. So what do I mean by that? Let's say you are um, again IIT Delhi, and you want to buy like 30 seats for your Introduction to Quantum course, which is going to be running for 3 months, right? So you say, okay, we want one organization with 30 students enrolled, and inside that organization, you're going to be having 30 standard seats, right? And also coupled with that, you will have like non-expiring quantum credits, which you can use for the next semester as well if they don't exhaust out during one semester, right? And don't be scared by seeing these prices. These are again US based prices. We offer very special discounts for universities and research labs. If you want to, let's say have a contract with qBraid for your labs or for your courses. And Digital Tech has been working immensely to, uh, increase our network throughout India. So we'll love to contact any one of you if you're interested in, running your course or running your programs on qBraid. I will again stop for questions here. I mean, the demo is kind of over because there's not a lot more to show. I would love to answer any questions and give out, contact details. If you guys want to contact us, you can basically contact us out on email, our website, LinkedIn, and you can, look at our docs and stuff like that. But yeah, it has been pretty great, connecting with you guys, and I'll open the floor for questions and any demos which you want to see again. I'd love to show you guys. Okay, yeah. um yep. Yeah, apparently I think the webinar is going to be ending like half an hour earlier, so I'm happy to give you guys that time for you. But any questions, if you guys have any kinds of details or discrepancies which you saw which you want clarified out or anything else, I'm here right now. Mhm. Okay. Mhm. All right. Um, Also, just one thing, these slides will be shared with you. So if you have any doubts or any things that you want to know, you can look, can go through these slides and just figure out whatever you want to know. Yeah. Mhm. Yeah, I think Govardhani, there aren't many questions at the moment. Do you want to like uh, end this session like in the next 5 or 10 minutes, or do you want to like do you have any other things that you want to discuss?
No, Ashit, like if they have no questions, we will wait for 10 minutes.
Yeah,
Let's see if they have any queries. We can
sure,
just
sure.
drop it in the Q&A session.
Yep, sure. And I mean, I think it would have been like, I don't think it would have gone on till 5 p.m. because all of these features are like very self-explanatory, right? And that is how we've tried to build qBraid. Like, there's not a lot to explain. There's just a lot to do with it, right? You go to qBraid and then you start doing stuff, right? So you can only explain so much, in my opinion.
Yeah,
Yeah.
explanation is fine. So the thing is, if they have any like clearance, like how to use this and any queries regarding that, like from their perspective, they can
Yep,
share
yep.
it in the Q&A. Because I thought that
Sure.
will be the elongated session, the question and
Hmm.
answer section.
Yeah,
But
yeah.
I'm not seeing any questions here yet.
Yeah, and I think as I showed you, right, if you have any doubts, you can just open that support ticket on qBraid account and we can get back to you as soon as as soon as possible. And yeah, that would be, I think, one of the best things to do if you have any questions after the session as well. Yes. Mm.
Yeah, shit, like I guess there is no any doubts, like queries from the customer side. If they have any queries regarding us, they can reach out to Digital or directly like raising the tickets too.
Okay,
I
sure.
think
Yeah.
we can end the session.
Yep.
So
All
thank you
right.
everyone once again for attending this 2 days FTP. I hope everyone got an overview about what is quantum computing and how to start with our qBraid platform and how to set up labs in your academics. Okay. So if you have any requirements, kindly reach out to us. So yesterday I gave you a mail ID as well as phone number. So you can reach out to us directly. Okay. Thank you, Ashit. I think we can end the session.
Yep. Thank you,
Have
everyone.
anything
Thanks
to
for
say?
being here. No, just wanted to thank you guys for arranging such an amazing session, and to our audience for being very patient and listening to this 2 hour monologue of qBraid. So I'm glad. I hope you guys enjoyed. And if you had any questions, any doubts, feel free to reach out anytime. And yeah, that's about it from my side as well. Thank you.
Okay, sure. Thank you.